Yeah, thank you, Partha sir. Thank you very much. I hope I'm audible. Okay, okay. First of all, welcome all, and thank you, Partha sir, for inviting me for this session. And it's my privilege to be on the platform with quite learned and scientific-minded people like you. And I'm not having the engineering background, so for the engineering part of innovation, particularly, I hope Robin sir will be the right person to make a comment on that. Yes, I am. Having a healthcare background, I'm a doctor by profession, working with, I have established my, there are almost 2, 3 startups in which, one in which I am a founder, one in which in two I am a co-founder, plus along with, of course, I am working with a lot of innovation sale and research activities regarding management and healthcare for a very long time. So I hope I can add some value to the panel. And today's, as all of you are well aware, it is a National Conference of Innovation in Engineering and Management. Particularly in the time where quite a turbulent time is there. In Maharashtra at present, we are facing a big surge of COVID again, and because of that, we are again into the uncertainty. So that is something now is a new normal, basically. Earlier we were used to some slowdowns and something in the economy, but now in new normal, what we expect is the uncertainty. So uncertainty will be the certain part of the macro environment for a very long time now. As far as what I see as a medicine person, that we are just facing the second wave of COVID, and without doubt there will be third wave, and possibly there may be a fourth wave also. So there is a still long time to come out of this. Okay, vaccination and all those efforts will help everyone to be building more and more herd immunity. But at the same time, what we see that there are a lot of adversities in the macro environmental part, and actually that is the time where more opportunities are also there. So innovation is expected when there are a lot of adversities, and at the same time, a lot of opportunities also come up. I am interacting with so many young entrepreneurs and innovative minded people since last 1 year who have started their things first time in last 1 year, and they are trying to scale it up also. So that is possible. It is not something that is not possible. So a lot of adversities are there and will be there for a very long time. Emerging economy, we call India as an emerging economy for a very long time, and probably with this will remain the tag for next at least 3 to 5 years. That is what I see. So in that period, there will be continuously new challenges in management, new challenges in engineering, new challenges in healthcare, everywhere. So you just named, even including the finance and automation also. So we talk about particularly what we say as a what is the scope and challenges in this particular circumstances. So what I see that there are those who are innovative minded. They can actually come up with a lot of ideas. Technology should be the backbone of these ideas most of the time, and means innovators should be able to find out what is the gap, because your product or idea may be great, but if it is not finding the right gap in the market, probably it is going to fail. There are many such failed examples in the market, so I don't want to repeat the same. But I would like to just suggest everyone that yes, innovation means everyone comes with the ideas, but particularly innovators and entrepreneurs, they have to work really hard to see that we work on those ideas and try to convert into something like a product or service which can be actually either documented or tested, validated. Because without validation, market is not ready to accept. I have means so many people come to me with some ideas and concepts, but if that idea is not validated in the market or with a certain number of cases, then actually what we expect as a VC funding and all the opportunities and everything, there it gets stuck. So I hope these small tips may help the young innovators who are going to present their research papers in this, that come up with the ideas. Some ideas are going to fail, but don't worry about that. Continuous efforts and repeated means efforts are needed. So that is something what we have to look for. So let's see how we can take it further in today's session. And I think, Robin sir, I would like to hand over to you for the further proceedings if it suits you. Yeah. Yes. Yes. Okay. 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 Let me. Yeah. Rural. Okay. I also come from a Western Maharashtra, small city. Now it has become a big city, Kolhapur. But still, it is a distinct place only. Means, and I'm born and brought up in small, very small towns. But somehow could manage to means put up my feet on some international stage for now almost a few years. So actually in rural areas, the problems are still agriculture based, service based, and there are many means I can give you one simple example from agriculture based, that there is always we talk about abundance of food or shortage of food, or we talk about uncertain weather. Yes, yes, uncertain weather, and then our crops get ruined. So these things actually can be handled with the help of the technology, sensors, biosensors, or so many other types of things. And these so many things are easily available there. There are a lot of open source ideas which are there on the internet. So people have to just look for it and try to find out what suits to find a solution for my problem. Because again, every rural area has got, then there are a lot of local problems also. It is, yes, we expect in entrepreneurship that the idea can be mega scaled afterwards, but at the same time, first what India needs, I think what Partha sir said rightly, that What rural India needs is a social entrepreneurs, not the entrepreneurs only with the commercial mindset, but the social entrepreneur means an entrepreneur who will do the entrepreneurial venture. At the same time, he will actually add some value to the society, and he can solve the problems in the society nearby him. It is not that sitting in some small town, I am expecting to make some impact on Delhi or Bombay. So that is, instead of that, if I can make an impact on my village, my nearby town, what we have seen in the movies like Swades or many such type of movies. So that is something actually India needs at this time. And for that, if we can come up with small ideas, like there are many people who means what I see, because there are a lot of agro business management students in my institute, and what we have seen that they come up with excellent ideas and they become successful in handling that. Another example can be given with the dairy. Now, means dairy industry, which can be developed in any corner of the India, any smallest of rural areas, wherever there is a space and government is ready to fund you, government is ready to give lot of, there are so many schemes are there. So, but what is needed for the market is now, if you see that nutritionally, now A2 milk is in demand. So for that, you need a, means A2 milk and A2 milk products can be exported also. But for that, what we need is again the hygiene and the typical gene of, means only gear type of cows or certain types of cows, and then you can convert that. There are a lot of automations can be done, a lot of means minimum handling of man, and still we can enjoy a good results from the dairy industry. So dairy, poultry, agriculture, these are the areas which are from actually rural background, which can actually think about innovation in these areas. This will help us more instead of just trying to create a one app and try to solve the problem, because everyone is what is they are doing is creating an app, and that is something many times is not sufficient, because that app if not utilized at certain level, again that idea is going to fail. So see that what is the basic. Yeah, so everywhere means how technology can be utilized for the advantage of humankind and solving the social and local problem. If I think this is a something what one liner, if young people can keep in mind, I think they can be successful, and I would like to wish all the best for them. Pata sir, I should not take much time. There are so many people. Let them present their papers, and let Robin sir also say a few words about this. Yeah. Yeah.
May I know my time slot, sir? If you give any direction, I will follow. Okay. Very good afternoon to all. At the outset, I would like to thank the organizer, my friend Mr. Pata, for inviting me to share my knowledge as well as to assess the innovation done by the young researchers in this forum. So conducting conference is not so easy, and conducting quality conference with quality publication is another milestone. Now, Mr. Pata has achieved it. He identified quality journals so that he has received more papers from the researchers. Thank you, Dr. Atul sir, for sharing your thoughts on innovations, and you have touched almost all the corners of innovations. You know, my presentation, my talk would be on the engineering aspects, the components which you missed out. I hope I will give the flavor. I will add the flavor to all the participants.
Yeah.
Hope all the participants are receiving our inputs. I think so, because meeting the crowd in the virtual mode, even after lunch, the post-lunch session meeting or giving a presentation, even as a professor handling class after lunch is very, very, very difficult. Yeah, I have just straight away I came from my lunch for your kind information. It's a challenging task to both presenter as well as the audience. Anyway, I hope I will share my thoughts on the role I have. Assigned to me is to fetch the intellectual property right. The role of intellectual property right in innovation ecosystem. This is what the topic I have preferred and I have given to talk to the audience. What is innovation ecosystem? Before that, we need to know some terminologies. The terminologies is very common. So whenever I address the people, I used to say that people have discovered a lot. People have invented, our forefathers, our people, the scientists have discovered a lot, invented a lot. Discovered means Columbus discovered America, and now I don't want to mention their name, but they are ruling the America. Vasco da Gama discovered India. People are ruling India. They are enjoying. We are all enjoying discovery. So we are not calling anyone to come and discover something. At the same time, we are not inviting anyone to invent something. Though it is encouraged to invent something, but need of the hour is not that. When Thomas Alva Edison invented electric bulb, we are not using the same electric bulb when Thomas Alva Edison invented. So the time is now. We are need of the hour is not discovery, not invention. The need of the hour is invention. Need of the hour is innovation. We are not calling you to discover something. We are not. Sir, Pata sir, can you mute your mic?
I think Pata sir is getting review for Atul sir has spoken.
Yeah.
Yeah.
Hi, Rajkumar, how are you?
I'm fine, sir. I'm fine, sir. Thank you.
That's nice to meet you. So we are not calling you to discover something. If you discover something, it's well and good. The same way, we are not calling you to invent something. If you invent something, it's well and good. But what is the need of the hour is innovate something. So innovate something is nothing but innovation is nothing but the same thing. Discovery is nothing but one finding out which is in existence. Discovery. Invention is nothing but finding a new. Innovation is nothing but making something on the invention. Thomas Alva Edison, when he invented electric bulb, we are not using the same. We are using the innovation of electric bulb in the form of maybe LED bulb or other variants. You can do innovation in anything, whatever you are. Today, I'm sitting in front of a laptop. I am using a table. You can make some innovation on the table, and you can give it to the market. And I have my mobile phone, this mobile phone, Apple mobile phone. So you can do any innovation on this, getting the existing product, getting the existing specification. You can make something. Even you can make something on the cover, which I'm using this iPhone. You can make some innovation over there. So you can make some innovation with this pencil. I'm right. A pencil is in front of me in my table. So yesterday I have seen one article. So we are wasting lakhs and lakhs of trees every year, cutting trees, lakhs and lakhs of trees for making pencil. So one innovator have manufacturing this pencil without the wood, and he used only the waste papers, and those materials is using to make pencils. So these are all the innovations. Friends, we are living in the 21st century. The innovations we are enjoying. We are sufficient. We are enjoying the innovation in the field of electrification. We are enjoying the innovation in the field of automobile. We are enjoying the innovation in the field of airplane, water supply and distribution, electronics, radio and TV. Yesterday, we have launched the college which I am working, Sairam Engineering College. We have launched one Sairam radio campus, and exclusively radio channel for our institution. It is in podcast. So when I say podcast is a new media, innovation in the media world. So whatever you can raise your voice can be, it helps to reach the globe. So I have found some innovation over there. Radio and television, agricultural mechanization, computers, telephones, air conditioning, highways, spacecraft, internet, imaging, household appliances, almost all the household appliances. I refer one particular product. The product is grinder. So gone are the days we know our forefather, our grannies, how what kind of grinder she used. They used the only the stone. Then we transformed to some other machine. Then now the recent innovation over the grinder, without wetting our hands, we can get the flour from the grinder. So they have given a small opening at the bottom of the grinder. So it will automatically, once it is grinded, if you open the knob, automatically the grinded flour will be ejected, so that we can collect without wetting our hands. A small invention, but it has a lot of people are liking it and try to get it. So we are enjoying the petroleum technologies. We are enjoying the laser and fiber optics and nuclear technologies, high performance materials. These are all some of the innovations we are enjoying in the 21st century. Okay, so the need of the hour is something different. Once it is invented, innovated, we need to claim the rights that we call it as intellectual property right. Gone are the days, the wealth of a person is normally measured with the help of amount of land they possess, movable property and immovable property. If during this election time, if you see the candidates' wealth, all are disclosed in the website. If you want to select a candidate based on their thing, you can go to the website and see all the candidates and their movable property value and immovable property value. Then you can, that one of the parameters you can decide and to vote for a candidate. So gone are the days, even still the trending is going on, but the days are coming very nearer to you. Your wealth will be determined with the help of the amount of intellectual property you possess. So the days are coming. So you need to equip. So that is what the awareness. Wherever I go, I spread this awareness about the importance of intellectual property rights. Intellectual property right is very important. You need to have the rights of your idea, your process, your product. So this is what intellectual property right, a small introduction about intellectual property right. Let me move to the innovation. Innovation, Dr. Atul sir clearly mentioned about innovation. You have to, once the product is ready, you have to validate it properly, and you have to make the user or the customers to use it. So shall I give a small formula? If you have a notebook in your hand, kindly write it, because recently I have joined as the Dean Innovation in Sairam group of institutions. I think Sairam has taken a step of promoting the innovation in the campus. For that, they have recruited me and given an exclusively title Dean Innovation. They have gone through my profile during the interview. This particular post is assigned by our chairman. Even I was thrilled. What is innovation? What as normally a professor will? I'm going to be professor. I am basically a teacher. Saying, I'm very happy to say a teacher rather than professor. So we want to be with students, and whatever we have, the knowledge should be transformed to the students. We have to evaluate their projects, reports, and PhD scholars are there. 6 scholars have successfully completed PhD under my supervision. 10 students are doing their research. So what innovation I can, because I was knowing about the proper definition of innovation. The search started, and it goes like that. And one particular day, one particular definition I got, a clear definition. That's what I'm going to give this formula of innovation. If you have a paper and pen, kindly note it down. Innovation is equal to invention multiplied by commercialization. Invention multiplied by commercialization. Invention is nothing but your idea. Your idea. Commercialization is nothing but you have to make it, you have to put it in the market, and you have to generate some money out of it. If you are very brilliant, you have a lot of ideas, and you are capable of developing product, and if you are not commercializing it, you're not throwing it the market, you are not getting the right customers, and you are not earning out not anything out of it, then you can't claim that as an innovation. At the same time, you may be a millionaire, billionaire, and you are capable of investing many things, and if you don't have any idea, new idea, then you cannot claim any innovation over there. And the particular professor coined very carefully, it is not invention plus commercialization, it is invention multiplied by, the strength of multiplication over than addition. So innovation is nothing but, friends, if we have idea, this is the right time, because even in all our government websites, especially the AICT, Ministry of Education website, especially our Honorable Prime Minister, wherever he addressed the youngsters, used to say that you have to become the job provider rather than being a job seeker. So this is a need of the hour. If you become a job provider, then only we will be in the sustainable development. That is going to be the contribution for the sustainable development of the nation. So now you have, what is innovation, and what is innovation ecosystem is nothing but this ecosystem must be brought to all educational institutions. That is what AICT or the Ministry of Education is always insisting the educational institution to follow all its initiatives like National Startup and Policy. So a lot of steps have been taken by the Government of India. If you visit the Government of India website, so I will give a small tips. If you visit mygovernment.com, it's a website, it's a sectionate company where you will get all the details of the government initiatives. If you go there, you will get a lot of insights over there. You can see the government initiatives. So an innovation ecosystem is need of the hour. Every institution must adopt it. And what are the components you have? You have startup components there, entrepreneurship component is there, intellectual property component is there in the innovation. So you need to conduct a lot of ideation. So how to achieve this ecosystem is, we have idea. We need to conduct the ideation camp, ideations, collect the idea, and convert the idea into product. In between, we have a process called boot camp. We need to conduct a lot of boot camps to make the ideators to convert their idea into prototype. Once it is converted into prototype, we have to take steps to convert it into product. For that, we need a strong technology background, the technological training, then one, we need to identify the ventures. So here, Mr. Pata is taking a wonderful job on uniting or bringing the ventures and the ideators. He is playing a vital role. Actually, this is very important for every academic institutions. When I gone through his initiatives in the website, when I interacted during my interaction with Pata sir, I have understood very clearly what is focusing is need of the hour, and every institution must adopt it and must provide a channel for this kind of initiatives. So you have to become, if you want to become an entrepreneur, you need to have the excellent leadership skill, and you need to be a good dictator, and you need to be a creative and innovative person, and you need to have the ability to judge people, and you need to have the better, excellent manager, and you need to be a communicator. So these are all the basic requirement, and it is possible to achieve through research. When I talk about research, and I have research on one hand and entrepreneurship on the other hand. So sometimes these two will contribute, complement each other. When research is complementing the entrepreneurship, we call it as mutualistic relationship. So this mutualistic relationship, if it is strong in an education institution, definitely you're in the way you're fully aware of the innovation ecosystem. So we please support all the initiatives of the government of India, especially National Student and Faculty Startup Policy 2019 and the National Innovation and Startup Policy 2019. Professor Ashok Jinchinwala is the chairman and is doing a wonderful job. What IIT Madras is doing now, they are encouraging all the education institutions to do it, to follow the same. So we have the veterans in the field. If you follow it, definitely we will get a lot of things. So coming to the intellectual property right, we have a lot of different types of intellectual property rights are there. Design, industrial design. Even the pressure cooker which we are using at home, the whistle are placed at the top of the cooker. It has its own industrial design. And we have trademark, we have geographical indicators, lot of geographical indicators we have, and copyright, then patent. So you need to go for, in India, if you go for a patent, they normally, the softwares, they'll not provide a patent, but if you go and approach US Patent Office or the Australian Patent Office, they will help you to go for your patent. So this is the right time to know more about the patent and copyright. You have to need a search on the patent. So patent search, if you want, you can say research as I normally experienced during the project review and other thing. The students, what they know is they know Google Scholar and some databases, Elsevier database or Scopus database. If they have subscription, they will get more access on those research papers. Indian Patent Office, official Indian Patent Office, then US Patent Office, then European Patent Office. 4 databases I've given the demo on how to search the database and how to get the required document. All the documents which are patented are already been disclosed to the public. If you know the technique, you will get all the technical details, all the specification. So if you have the specification, then that is the first step of your innovation. So kindly share your knowledge to everyone, because India is a country where we have more population. So educating them and it's very difficult nowadays. We thank God that this kind of platforms are helping us to reach more people, and I'm reaching more people every day. If I go to my YouTube channel, minimum 50 to 60 new people will come and visit and get knowledge out of it. So I encourage everyone to visit those things. I have shared very little knowledge, information, and a lot of videos are available. I encourage everyone to go through it and share these videos and subscribe my channel. And whenever I come online, you will get notifications so that the knowledge sharing I can share my knowledge to you. So with this small introduction, I thank the organizer for this wonderful opportunity. If time permits, in between, definitely I will interact with you. So thank you so much for listening my lectures. I hope everyone is listening me, though it is a post-line session. I strongly believe that you are listening and receiving my input. Okay, I will come back whenever I will get a gap. Thank you. Over to Bata, sir.
Yes, sir, I'm here. Yes, sir. So, good afternoon, respected dignitaries. I'm Akhil Verma, and my partner is CH Tejanaidu. And we have done a research project on crop yield prediction using machine learning techniques under the guidance of our professor S. Nciem sir from SRM Institute of Science and Technology. And my teammate is going to present his screen now.
Excuse me, sir. I have an issue presenting this. I'll rejoin now.
So, like, just a second, so my teammate will come back in a second. Sorry for the inconvenience.
Yes, sir. Yep, I'm here. Okay, sure. Yeah, can you see me? Yeah, my topic today is cited TCR with domain custom tokens. It's a blockchain and solidity based project. I have my teammate Amar here. So I'll just present my screen. Okay. So yeah, this is my topic. Good afternoon, everyone. So cited TCR with domain custom tokens. This is my teammate Amar. My guide is Mr. S. Nciem. So first we'd start off with what is a token curated registry. So if you're not very familiar with blockchain, don't worry about it. I'll try to walk you through what we're trying to accomplish here. So a token curated registry is basically a crypto system which was created by Mike Golden, and he wrote a white paper about it. So the main objective of this system is to create a high quality list, right? It's to incentivize the public, the participants to get together and curate a high quality list. The items of the list can be anything. It can be ranging from books to restaurants, and in our case, the use case that we're using, research papers. So this is the basic working of a TCR. So how it works is, suppose you want to apply, you want to submit an application. For example, I want to submit my research paper, right? So after submitting an application, we pay some kind of fee, which is known as a stake. So this stake is paid in the form of tokens. How that is done, I'll show you clearly at the end of the video. So after you submit an application, it enters a sort of challenge mode where token holders can vote on whether that application is good enough to stay in the list or not. And depending on the results of that vote, you'll be rewarded, or you could if you fail the vote, the deposit you've given will be forfeit and will be split among the people who voted to reject your application. So that's a kind of basic understanding of what a TCR is, and that is the present system. So what is a cited TCR? So a cited TCR is kind of an expansion of that concept. So for a TCR in general, the curators are assigned randomly. So this isn't a huge problem when we're talking about lists that are curated that don't really require any expertise to curate. Like for example, books or food, things like that. But when we talk about topics like a research paper, for example, we require the curators to have a certain amount of expertise to actually know what they're voting about. Otherwise, it could lead to us creating a very low quality list. So yeah, how the cited TCR accomplishes that is by using something called a personalized page rank algorithm. What a personalized page rank algorithm is it's an expansion of the page rank algorithm. So the page rank algorithm itself was created by Larry Page from Google back in 1996. So what it does is it basically calculates the importance score of a particular node. And in our case, each node is a curator. So in layman's terms, what it does is it calculates the importance score of a curator, and based on that, it will give the curator the right to vote on whether that application should stay or not. Okay, so this is a small introduction on a TCR, not a cited TCR. So suppose we have a token curated registry which is centered around making a list of the best restaurants in Chennai. So there is a market for that. I can say you might have read in magazines there are lists like the top 10 best colleges or the top 10 best restaurants, for example. Now the problem with these kind of lists in magazines is that they can be easily gamed. What I mean by that is, suppose you're a famous restaurant and you want to enter this list, but obviously you want to be the first in that list. So there have been cases where you can pay the magazine a little bit of extra money, and they'll put you on top, right? But in this kind of system which I'm proposing, that's not possible, simply because it's a decentralized list. It's not centralized, so there's really no one to pay here. um, so yeah, in this example, we have a restaurant that wishes to be part of the list. So they pay an initial deposit, say 100 rupees, and you transfer that into tokens, and then that application enters a challenge period. When it enters a challenge period, the general public, people who hold tokens, will look at that application and will see if the restaurant is good enough to be added or not. Now, one thing I forgot to mention is that the way the system works is the first instinct of a voter or a token holder is to reject an application. This is because as you can see, the candidate pays an initial deposit, right? So if they lose the vote, the initial deposit will be forfeit, and it will be divided amongst the token holders who voted against it, right? So if the token holders reject an application, they will get this initial deposit. So that is why their first instinct is to reject any application that comes along. Now, why they can't, why this isn't a good long-term plan is because they get paid in the form of not actual money but tokens, and the value of tokens really depends upon the value of the TCR as a whole. And if they reject every application that they come across, then the list won't have any, it won't hold anything, and therefore it won't hold any value. And as a result, the tokens that they get will have no value, so there's really no point. So the token holders are forced to really look at the applications and actually check if these restaurants are good or not, and accept them if they are. So they have these restaurants, as a summary, the restaurant has to be really good to be accepted into that list, and therefore we kind of create a system where we get a list of really good restaurants. So that's a small example. In this case, we don't use any PageRank algorithm or any such thing, because we don't really need any specialized expertise and knowledge when it comes to curating a list of good restaurants. Okay, so this is the problem statement basically. How does the system benefit us? Like I explained before, there are this market is already there, where magazines or newspapers publish their lists of top 10 good colleges or top 10 great restaurants, and these kind of systems, as I explained before, can be easily gamed. So what I'm trying to accomplish here is that the lists remain of high quality, and we get the truth all the time. And one more aspect that I'm adding to the thing is that the list shouldn't get outdated. So especially in research papers, sometimes the papers get outdated. After a couple of years, a new paper comes out with new knowledge. So it's important to stay relevant. So yeah, that's the problem statement. So this is like a rough estimate of the number of research papers published per year. I believe in India, around 1,35,000 research papers were published in 2018. India is probably the third largest country that publishes research papers. Coming to the present system and how it's already been implemented by Mike Golden and his team. So how it starts off is a user basically stakes some tokens and gives his application for review. That gets locked, and they get a lock ID, and a new application process is started. And then we go to the challenge system, where the voting process starts. So after the voting process is closed, which we have to check, there's a parameter that we have to check for. In case there's a draw, like the number of for votes and the number of against votes are the same. In that case, if the number of for votes are above a certain threshold, then it will be accepted. Otherwise, it will be rejected. Then we come to the reward system. So the reward system is a very peculiar part of the TCR, the cited TCR particularly, because in a research paper I was referring to, they use something called a peer prediction mechanism, which I will explain in a later slide. Okay, so the downfalls of the current system. So these are the problems that I'm trying to fix with the new system that we're trying to implement. So the first problem is the curators are assigned randomly, right? Any token holder can vote on whether an application is accepted or not. So this is a huge problem when we're talking about lists that require some sort of expertise, for example, research papers. And the second problem that I have to expand upon is that smaller token holders have to pay a relatively high gas price to stake their tokens. So if you're not familiar with blockchain, I'll briefly explain what gas is. So gas is basically the price of computing or verifying your transaction on the blockchain. So basically, if you want to run any code on on a blockchain, you have to pay a certain amount. The situation I'm talking about here is, suppose you're a token holder and you used to place one vote. Then in some cases, yeah. Okay, because I'm not very sure if you understand what I'm talking about. So I'm expanding on it a bit. If you know what gas prices are, then that's fine. I'll go for the next one. These are the ways we overcome these problems. We use PPR, and we use whales, which are basically larger token holders, where smaller token holders can entrust their tokens to these whales, and the whales will vote in their stead, decreasing their gas price. So I've added a couple of other innovations. Basically, each voter will be allowed to place only one vote. This doesn't mean that one vote equals one token. No, one vote will be probably more than one token. It will depend on the deposit that the applicant puts forward, so that the voters are incentivized to do something about it. Then about whale accounts and how they have some special permission to place more than one vote. Tokens will be domain specific. I think that's a given, because we don't want any competition between different domains, because that will be irrelevant. And tokens will be perishable, so that everyone is on top of their game. The candidates, the people who are voting, the curators have know what they're doing. So these are some of the algorithms that we're using. PLCR voting allows you to stake tokens in more than one event at a time. Peer prediction, as I've explained before, it allows us to verify whether someone has voted properly or not. And PPR is also something I've explained in a previous slide. So this is exactly how voting works. Basically, we generate a unique hash of the vote you've placed, and that hash is distributed to the public. And as soon as all the voting period is over, this hash, a public key will be distributed, and your vote can be verified. Yeah, I had a small demo for how this works, because in my previous review, the faculty wanted to understand what a TCR was. So this is what a normal web application looks like. We have a front end, a back end, and a server, a database, and users. Compared to a blockchain application where the front end remains the same, but instead of the middleware and the back end, we have the Web3 provider which connects to a blockchain. Yeah, so this is the in this demo, you probably won't understand, but this is the address under inbox right here. We have the addresses of several accounts that I use, sample accounts that I use with Ganache. These are some of the boilerplate requirements, and these are the references I used. So just a little bit. Second. Right. So I'm aware we don't have much time, but I did code this, so I like to show it for a couple of minutes. Right. So this is a basic TCR that I made. It doesn't have all the functionalities that I talked about, but
Mr.
basically,
Thomas, if you go for the evaluation part, we'll be happy.
okay.
Okay.
That was the end actually.
Have you evaluated your work?
Evaluated in what way?
Have you tested it?
No, I haven't put it on a mainnet as of now. That's actually a little too costly.
Okay.
Yeah, that's fine. Since we're short on time, I'll stop here. Yeah, yeah. See, the thing is, the tokens that we're using, we can definitely. I believe India is, coming up with their own official token. So, when that comes out, we could, shift to that. But and as of now, I'm just experimenting with it. I really have no plans on commercializing it right now. Yeah.
No, nothing more specific.
Yeah.
Yes, sir, we are ready. Yes, sir.
Sir, is my screen visible?
Yes, yes.
Okay. Let me start the presentation. Good afternoon, respected dignitaries. My name is Tejan Naidu. My partner here is Akhil Verma. We have done a research project on crop yield prediction using machine learning techniques under the guidance of our professor Nciem sir from SRM Institute of Science and Technology, Chennai. This is the abstract part. Yeah. So as we know, agriculture plays a very important role. No, sir, it's a bit different from the other papers. Yeah.
Okay, sir.
Actually, we gave you a pre-recorded presentation of this also. Yeah. Anyways, I'll continue with the project now. As we know, agriculture plays a very important role in every economy. India being an agrarian country, agriculture is the backbone of our economy, and yet our farmers remain poor and widely in debt. So we want to remedy the situation by giving them an estimation on the amount of yield they are going to harvest if they plant a certain crop before they even start cultivating it. In this way, we can increase their profits as they can decide which crops to grow beforehand. Our main objective here is to train a machine learning model which can accurately predict the yield by using previous year data and see which model works best for these predictions. Our data set consists of weather and other soil parameters which contribute to the crop's growth. Machine learning techniques are used in a variety of fields to predict an outcome or to classify an object because they are quite accurate in their results. Crop, crop yield prediction being one of the most challenging problems in agriculture, we decided to train a model using machine learning techniques. There are a variety of factors which affect the crop growth, and because of that, we have to implement several data sets to predict an accurate yield. We are implementing regression techniques to predict the yield. There are several machine learning techniques which can be used to train the model, but we need to choose a certain model which can go hand in hand with our data set, and also it should be able to handle large amounts of data. According to a survey in 2018, more than half of our country's population is based on agriculture. Yet, only 17% of our country's GDP is amounted to that population. So, farmers today grow crops based on information gleaned from previous generations. Since the traditional practices, there has been an abundance or lack of such yield without collecting the real need for planting a specific crop. So we would like to help the farmers by giving them an estimation on the yield they are going to harvest if they grow a particular crop. Now, coming to the data set part, we decided to implement this model in the state of Maharashtra. We acquired a district level information containing previous year's climate, soil, and yield parameters. This information was gathered from Indian agriculture website. The dataset contains 18 years of data on the climate and soil properties of every district in Maharashtra. We applied data pre-processing techniques to remove any outliers we have in the dataset. Then we implemented one-hot encoding so that it is compatible with all the machine learning regression techniques. Yeah, to cropping seasons of India. To simply put, India has two cultivating seasons. That's Kharif and Rabi. Kharif is from July to October, and Rabi is from October to March. Crop season, like name, district, along with some other climate features like humidity, precipitation, temperatures, are considered as an independent variables here, and the yield is taken as a dependent variable. Now, a few of the challenges we faced during this project are selecting a suitable district data set and pre-processing which can make the project more desirable to get a better result. Then regression model training must be done using less computational power. More error rate due to continuously changing environments in the districts. Yeah, so we have looked into 10 research papers on this particular topic. We found out that most of the existing systems use very less number of parameters to determine yield, whereas in real world, crop yield is influenced by several weather and soil parameters. Most of them used only 1 to 2 machine learning models, which gives very less scope for comparing the performance and deciding the best model. So what we did is we implemented 4 machine learning models and we compared their performance using various metrics. Some of the models other implemented are crop specific, whereas we have selected parameters considering on applying the model on any crop. So this is the architecture diagram. The above block illustrates the components of the systems and how they function and how the data is taken from the agriculture website and pre-processed. During the pre-processing part, we remove null, extreme outliers, and repeat values using the Python libraries like NumPy and Pandas. Then we perform the exploratory data analysis. During this phase, we analyze different parameters, understanding patterns and how they affect the crop yield. We have split the data set to train and test data, 80 and 20% respectively. Next, we decided which appropriate regression models to use to fit the training data. We applied those machine learning models that can use new data and make predictions. Now, we collected an agriculture data set, which is .csv file for crop yield prediction. It has different district-wise parameters like temperature, precipitation, humidity, soil type, crop type, season, area of the field, etc. We have done one-hot encoding in order for the models to take categorical variables as inputs. Now, coming to the exploratory data analysis part, EDA is a very important step as it encapsulates the important properties of the data by plotting which contains scatter plot, histograms, bar graphs, and so on. It involves various steps from data pre-processing and coding categorical variables to bivariate analysis. Now I'll show you a heat map using Seaborn. Yeah. This following plot is a heat map using Seaborn library. It shows the collinearity between all the parameters which have done one hot encoding, and it created all the extra features. We also checked for the threat of multicollinearity and got a variation inflation factor less than 5. Yeah, I would like my partner to take over from here. Okay.
Yes, thank you. So formula. For understanding the model performance, we used metrics like R square. It ranges from 0 to 1. From that, the accuracy is calculated by multiplying that value with 100. We compare the efficiency of these models by using another metric called mean absolute error. Lower the mean absolute error, better the model performance. The above slide shows the formula for these metrics. Next. So algorithms. We have used 4 machine learning algorithms. Our first one is multiple linear regression. It learns the connection between a dependent variable and several independent variables. It is the simplest form of regression models, and it is not penalized for picking any weights. Although this poses a risk of overfit, but there are ways to avoid that. The following slide shows the formula for multiple linear regression. Next. Our second model is decision tree regressor, which performs well for both classification and prediction. It divides the dataset into smaller subsets. A tree with a leaf and decision nodes is the final product after doing the decision tree. These models do not require much effort for pre-processing or data normalization or scaling. Next. Our third model is lasso regression. It is a modified multiple linear regression that uses a hyperparameter alpha that is used to correct the weights. It can also avoid overfit even on smaller datasets, and is also faster during the training. The above slide shows the formula for lasso regression. Next. Our last model we used is ElasticNet that combines the functioning of both ridge and lasso regression. It can deal with a dataset which has more parameters than the data points. It can decrease the effect of various parameters uh, without completely removing all of the parameters. The above shows the formula for ElasticNet. So at last, like we have successfully trained these 4 models, and we have used R square, mean absolute error, and real versus actual value scatter plots to compare the performance and calculate the accuracy. Next. The above graph shows the R square values for the following models. We can see that the decision tree regressor got the highest R square value, and ElasticNet got the lowest, and multiple linear regression and lasso got similar results. Next. R square is also called the coefficient of determination, which shows the uh, variance of dependent variables with the help of independent variables. In the above table, we can see the accuracies of the models we achieved. Next. This plot shows the mean absolute error values, uh, which is a metric used to determine the mean estimation of errors during the prediction. The, the lowest mean absolute error is achieved by decision tree regressor, and ElasticNet got the highest. Next. The above plot shows the real versus actual value scatter plots, which help us understand how well these models fit with the data. Ideally, all the points should be near the diagonal line. If a model has better R square value, all the points will be closer to the diagonal. For the models which have lesser R square value, the points will be more distributed. From the plots, we can understand that the decision tree regressor shows the best fit. Linear and lasso regression showed a little overestimation of the values, and ElasticNet showed a little underestimation of the values. Next. So from the performance of these models, we understood that decision tree regressor gives the best accuracy, which is 83.6%, and also has the least mean absolute error. This proves that there is a great connection between yield, soil, and weather parameters. This helps farmers decide which new crops to try out in a certain farmland, and therefore they can make better profits. This also contributes a lot to the Indian economy and uplifts the rural areas as major population cultivates crops as as their major occupation. This project can be improved by extending to merge with other forms of agriculture like sericulture, livestock farming, pisciculture, and others, therefore contributing towards the agricultural development in India. Next. So these are the papers we have referred for our project. Thank you. So all the districts of Maharashtra, sir. We have gathered the district-wise data for all the districts. We have taken temperature, precipitation, humidity, the area of the field, and the soil type. Like the soil is chalky or clay, like that, and the crop name, and all these are taken as parameter. It is, for example, rice, bajra, and also wheat. These three crops. No, sir. No, sir. No, sir. Like like all those parameters, like they vary a lot from field to field. No, sir. That's why like we want a project that can be implemented on a larger scale. Like it can be diversified and it can be used for other like other types of agriculture too, like pisciculture, sericulture, and all.
Yeah, I know the size of the data set I have considered.
So the data, so the size of the data set is around 2,000 rows,
Hmm.
and after one hot encoding, it was 55 columns. So,
Okay. Hmm. Since you have considered all the districts,
yes, sir, all the districts.
okay. Do you have any district-wise distribution?
Uh, like we have district-wise, we have all the climate parameters for the fields like that we have.
Prediction.
Yes,
You
sir.
have to do that analysis, no? Am I right?
Like we have the yield values for each district, the
Hmm.
farmlands, and the crop types and all, and like that we have.
Okay. Why you have restricted only three types of crops? Do you have any specific reason?
Not any specific reasons, sir. Like, but we found only that data set with a like with enough number of parameters to be able to use for machine learning models.
Okay. You have to consider more data sets so that only you
Yes,
can come to. Your claim is on the decision tree is better. Am I right?
yes, sir.
Okay. Why you have taken only four algorithms? Do you have any other algorithms?
Like
What motivated to restrict only with four algorithms?
like when we are reading like other papers, we have found that they are only considering like one or two machine learning models. Then like we have seen like what all regression models perform the best, and we have done the project on these models. So we have selected four models out of that.
Okay. And your claim is based on only two metrics, R square and mean absolute uh,
Error.
error.
Yes, sir.
Hmm.
Okay, sir.
But these two parameters, with only these two parameters, you cannot come to a conclusion.
Okay, sir.
Do you have any specific
Also,
reason of not considering other parameters, other metrics?
uh,
You have to
like
consider.
there are other metrics like RMSC and MSC.
Yeah, sometimes
Mean.
if you are not doing research, I encourage you to research so that even they may produce some negative result. Don't get disappointed. Okay, but anyway, you have to explore with other methods.
Okay, sir. Thank you. We'll do that, sir. Thank you, sir.
Okay. Thank you.
So can we present before them? So I know I have a later turn, but can we present before? Okay, okay.
So should we wait or should we present? Yes, sir, I'm here. Can you hear me? Yes.
Okay, sir.
So can you see my screen? Yeah. So hello, sir. I'm Vaishnavi, and my co-author is Prakhar, and we're guided by Rajkumar sir. And our paper is about hand gesture recognition and emoji prediction using surf filter and CNN. So coming to why we choose this topic is because when you are communicating with other person, hand gestures become important part of the communication. They also tell some amount of information that I want to tell it to the other person, and this paper will propose a efficient model which will predict that hand gesture, and it will like show a emoji on the screen. And we are achieving this by using CNN and many more filters, and one of them is surf filter. So for the model, we have taken our own data set. We haven't taken it from online. So the data set we collected it are from our friends and family, where we made sure that most of the images will differ, based on the skin tones or the orientation of the gesture and the angles and the lighting conditions. And in fact, we also have taken gestures from people who have tattoos on their hands, so that we wanted to make our model more robust. So so now, why emojis? Like, why have we? What is the need of what is the need of converting those gestures into emojis? It's because if you observe in any chat application, when there's a flow of conversation, you mostly communicate some of your feelings, not through sentences but through emotions, like through emojis. So emojis have also become a part of our another kind of social correspondence. So it is, it can strengthen the structure for the communication. Like if you want to say okay, people nowadays just use the okay gesture, hand gesture. So it has become a significant piece of our lives. So we propose a model that will recognize the hand gesture in a picture or in a video, and then it recommends an appropriate emoji. So the proposed model can be used in the Google Meet, or video calls through WhatsApp or Snapchat. When there's a less data rate, as in if you're unable to properly see what the other person is trying to tell you, as in sometimes you only get the audio, but you don't get the video because the rate of data transfer is low. We recommend maybe using a model and then replacing it with an emoji screen, where your face would be replaced. Like not only the face, the whole screen will be replaced using the gesture that you make in front of your camera. So what will happen is you will be able to understand the other person well, as in even if you're trying to tell the other person something, and when you can't see his face, like for this meetings example, it's weird talking to a camera and a laptop in front of you, and without like understanding what the other person is feeling. So if you see a okay emoji or okay high five or some emoji on your screen, that gives you a you know information that okay, the other person is understanding the topic or not, or something like that. So um, this is it. Okay, why? Okay, instead of this model, you can go ahead and ask us. I can simply just choose and like I can develop a model which can just like it is just one click away or something like that. But you can see that in our reality, there are so many models that are being developed, which is which is using touchless interfaces. Like you don't have to touch a device anymore. You'll just it is either based on the they wear some kind of gloves and make a gesture, and the the model understands what you have made a gesture, and then it will whatever whatever you've attached to that gesture function, that will run, and the system automatically does its function. So it is been nowadays you don't. Okay, for example, if you have to turn on your TV, after turning on the TV, if you want to go somewhere else, there are models right now which will not use a remote, but it will just uh, guess your where is your hand, where is it pointing, where is your finger pointing, and it will take you to the application that you want. So now it's our everything that we're living in right now, it is converting into touchless interfaces. So that is why we have used to develop this model. And in the hand gesture recognition only, there are two types of approaches where one is the data glove one and other is based on vision. So in the data glove, what usually happens is that the people wear a glove which have sensors attached to them, and it will take meaningful data from the user who is using. And like even you must have seen people standing in front of a screen, and then they wear vision glasses, and they wear data glove, and they play a game. I so according to how user moves his hand, it synchronizes with what is happening in the game. So that is one type of approach that we have, and the other type is vision based, where there are no external sensors attached, but it only uses camera. This is more cost efficient, effective, and efficient, and it obviously generates a lot of data, and it needs to be processed by the system that you're using. So one is that in such models, you really need a very good system which has the capabilities of processing the data. So for our project, we are choosing CNN, CNN algorithm, which is a part of deep learning in machine learning. Um, why CNN? Why not normal ANN, which is artificial neural? Why CNN is because it is generally used to classify images and recognize images and to detect them in the computer vision. So, and apart from like in CNN only, we are using so many filters, which includes like Gaussian blur to blur out the backgrounds, and we're using surf filter, and we'll explain what surf filter is in a moment. And while developing the model, what are the challenges present is that the model that we propose has to be able to detect a hand present in the video without like telling the computer that where is the hand present, or it should be able to recognize the gesture apart from the backgrounds that is there in the images. So we have taken care of that by providing it a lot of different types of images where there are so much of like so much of objects in the background, so that it will be able to learn the network will be able to learn better. So we've handled that by developing a device data set. And the second, it should be able to distinguish from the necessary portion in the background of the image. So in the screen itself, it should be able to recognize where is the gesture present. So we've overcome this by uh, allocating a separate corner for the like for the gesture itself. Like on your screen, let's say I allocate top right corner of your screen to only put your gesture, and it should be able to predict accurately with good precision than the present models. We have we've read for more than 15 to 17 papers, and most of the things that they've used RNN, or they've used different filters. They've used support vector mesh, like other algorithms, and we were able to take out CNN to be the best algorithm from all the papers that we've read. And the surf filter that we're using is not is in the research paper that we have come across. The latest one was the SIFT filter. The surf filter is somewhat like a speeded up version of the SIFT filter, which has not been used till now. So we're trying to use, like, we use it in our model. And the last one is very important, that the model that we develop, it should not overfit the data, or it should not underfit, because if it overfits, then it will only work for the under specific conditions only. If it overfits, the accuracy will be low. If it underfits, it won't be able to predict the gesture properly. These were the present. And the architecture goes something like this. It takes the input from the camera. It takes only one section of the screen to take the information, and then it uses the surf filter. You process the image using this filter, which will take out the key features in the image, and then it passes to the CNN algorithm. And then you train the model, and then you predict the emoji. And this is our system architecture, and we've made the UML diagram accordingly. Um, this is a normal architecture where you have input layer, and these are the convolution layers, polling layers, and this process repeats 3 times. And in our model, we're using 3 convolution layers. Using more than 3 or 4 convolution layers is not. It's just the same, because it doesn't improve the accuracy that much. It just the accuracy almost remains constant after using 3 years. What is CNN? Yeah, CNN is convolution neural network. It is part of deep learning ANN technology, and it is very powerful when it comes to solve computer vision based challenges. And it is heavily used to analyze images and to recognize various significant features in the image. And okay, in each layer of the CNN, it depends on the previous layer patterns, and to make sure that it because it is depending on the previous layer, because we have to make sure that it is not training wrongly on the. It is just blindly depending on the previous layer. We have used filters in between so that it will reduce the noise in the image. We've used many more filters in between as well. Over to you, Prakhar.
Good afternoon, sir. So for feature extraction, we have used the surf filter. So here for extracting the feature, we mean that from the images there are many qualities which has to be guessed by the filter to get the correct prediction. So we have used many pre-filters like Gaussian blur, CVT color. Gaussian blur just remove some noises, and CVT color also changes the color shade, like from colored image to black and white shade, like that. So next image, Vaishnavi. So we have also for our each image in our data set, we have first we resized our image to our 2020 into 2020 form, and then applied a Gaussian blur to denoise the background background noises that causes some error in the prediction. So we have used the Gaussian blur, and further we have improved our data image processing using enhancing some image features. So coming up to surf, that surf is from most of the filters available on the internet right now. The surf has came to be a faster filter because it uses some integral images along with the box filter. So which is explained in the next slide. So the surf uses Hessian metrics and surf calculate the skills and locations accordingly. What it actually does is that it uses the hard wavelets. So it uses those wavelets in both horizontal and vertical directions. Next slide. Like in this slide, as you can see, that for each image, what surf does is that it uses the Laplacian of Gaussian box along with box filter. It uses integral image, but basically tells the pixel value of each part of the image. Like if the white part has a one value, the darker part will have a negative value, like that. So according to these values, it can predict the cumulative sum and tell the overall overall the final pixel result of that image. So in this the surf has two things to determine. One is description and one is orientation. For description, it actually forms a 20 into 20 size of neighborhood, which each is divided into four sub-regions, and that sub-regions the wavelet responses are taken, and the final value of the orientation is calculated using a spatial vector. The formula is like this. So as you can see, the summation of dx means the horizontal wavelets and dy means the vertical wavelets, and this determinant tells us the Hessian matrix determinant. Next slide, Vaishnavi. So in this, for the calculation of orientation, what basically it does is that it throws some wavelets on the. Suppose there is one important part of our image, so it will throw the wavelets on that image. So at a angle of 60 degree slide window is given. So on that angle, it will throw the wavelets. So it will then calculate the final direction of an orientation, like this red arrow. So this red arrow will tell that the final direction of the orientation. So if we using a upright surf, it can be increased or decreased 15 degrees in any direction. Suppose if we want to go in upper direction, then we use up surf or down surf. Next slide. So now we are coming to dataset collection. As we have told before, that each image in our dataset is special. It has its own twist. Has its own color, shapes, background, lighting conditions, etc. Thus, it makes our model more flexible and strong, more strong regarding to the type of input coming to our model. It can predict the images very well if it has different we can say different background, different textures, etc. So we have taken 10 gestures. Each gesture has 400 images, so a total of 4000 images collection is used for building this model. So this is the you can see that each image has own lightning, has its own uh, background, has its own coloring. So like that, different hands are shown, different, each hand is different, like that. So this is how the feature extracting is shown. Each each uh, each feature is marked with red circles, like this. Suppose this hand has some features on its finger. So on that finger, a red circle is shown to distinguish that feature so that that feature is visible. This is only for the visibility purpose. It is not like happening in the inside the model. This we have shown you so that we can show that how surf determines each and every filter here, like that. This is the sample output. We have shown each the gesture on a right hand side. There is a on right hand side there is a filter box. So at that we show our gesture, and our model predicts that gesture. If we don't show anything, then it will show nothing. Like in the last second last picture, third last picture. So
So
conclusion question.
yeah, so we have developed our model using a raw data set that we have developed, and our model it resizes and applies the filter, and then it takes into the CNN model and predicts the output. We have a total data set of 4,000 images, and our future work is to increase the number of gestures that we have. We've only limited our model to the hand gestures. In future, we expect to increase the number of gestures and increasing the data set for each gesture so that it will, not underfit the model. And we want to increase the accuracy of the proposed model. And we want to apply this model to a video streaming platform like Google Meet, so that in the Google Meet, instead of showing my stream, like my video stream, I would also like to implement the emoji screen that we have proposed. So that is our future work, and we have read a lot of papers, and these are the references. Thank you. Any questions you can ask? So, sir, in real life, when you are when we are like in our current situation, there are cases when the other person has very less, data rate, and the conversation is hindered because we are unable to understand what he's trying to express or what we are trying to express. And in our current situation, emojis and hand gestures have become a part of our conversation. Like if a person is talking, he has to express some points. um it's also because there's like some sort of confirmation that the other person is understanding. Let's say if you are teaching a class, and the other person face is not clear, and you are unable to understand if he's understanding the topic or not. If he just maybe tells, okay, I understood, there'll be a emoji present in your screen that okay, that person is understanding or not. Like if that person is happy, or like you have emotion. Yeah. Yes, sir. Yes, sir. Yes, sir.
Yes,
So as
yes,
we know,
absolutely, we can do that. But what is the thing is that if we show the face recognize takes more data to we are using for the lesser data as in most of the cities still proper internet is not available. So showing a hand.
yeah, yeah,
Yes,
yeah.
Yeah, it's a good work. I don't have much question, very few questions. Let me know um, the before feature extraction, before and after.
Yes, sir.
Yeah, before feature extraction, and how much parameters you had, and after how much you reduced.
Sir, we have directly jumped, like while developing the model only, we have directly jumped into using the like filter, the surf filter itself.
Sir, what we basically do is that before the extraction, there were many. We can say there were many. Uh, I can say there were many points that were distinguishing the result. Like background image was showing some another result. Some skin tone was showing some different result by applying some filters like Gaussian blur and denoising it like that. We have reduced the background distortions and some other disturbing light. There's some wrong lightning effects occurs on the screen. We have reduced that like that. We have used some more filters we have used before the surf. We applied some more filters like CVT color, like Gaussian blur, to reduce some background noises like that.
So if
And
you were
after the
asking, yeah.
and after the extraction, the distortions were reduced, the noises were reduced. Only the input was taken was of hand. Only the hand was taken into consideration by our camera like that, we can say, by our model.
Okay, have you done the data augmentation part?
Sorry?
Augmentation, have you augmented the data augmentation?
No, sir.
Hmm. Yeah.
Okay.
You,
So
you,
we'll consider it.
you have made a small attempt. Okay, we encourage you, we appreciate you, and
Yes,
we
sir.
enhance it.
Sir,
Okay.
if by augmentation, sir, you mean that yes, we have flipped our images some bits so that it can predict both the hands, left
Yeah.
hand and right hand. If that you are asking, that we have done that.
Then yeah, sir, we have included that in the database, and the model can different, like it can even if you show it with your right
Hmm.
hand or left hand, it will be able to predict the image.
Okay. You explore it. Okay. Good.
Okay.
Thank you so much, sir.
Thank you, sir. Thank you, sir.
Yes, sir. Sir, Vijayalakshmi. Yes, sir. Yes, sir. So, can you see my PPT? Okay. Good evening, everyone. My name is Vijayalakshmi, and today I'm going to be talking about our smart fill bottle using ultrasonic laser. So, as we all know that we're currently in our fourth industrial revolution, everything around us is being connected to the internet. And many industries, including manufacturing, marketing, and other industries, are using IoT and its devices to conduct their day-to-day activities. And medicine and medical assistance, along with compliance, is using IoT in a very major way to bring about a positive impact into it. But as we all know, currently during the pandemic, in the start of it, we had felt a very big lacuna in terms of medical assistance and compliance. We were not aware of how the virus was being transmitted and how people were getting affected by this virus. And because of that, there was a lot of hesitance in terms of taking care of the patients and other assistance that could have been provided to the patient but was resisted towards. But multiple IoT and its devices were implemented during the pandemic. For example, patient monitoring was being done with the help of IoT devices, and robots were being used to supply medicines and other amenities that was required by the patients and other people. So the objective of our particular problem here is to create a functioning pill bottle which will help us understand the drug intake habit of a patient, which will tell us the count of the pills inside the bottle when the bottle is being opened and closed, and um, every time the bottle goes below threshold value of the count, it sends a alarm through email to tell us when the bottle needs to be refilled and when the pill is being taken. So currently, in the existing systems, we already know that there are multiple mechanical pill bottles and pill boxes that are available. There are also a few smart pill bottles that are available which are using the sensors such as infrared sensors and load cell sensors. There are multiple commercial bottles that are available with their different styles and designs. But the limitations that we come to these existing pill bottles and pill boxes is that the value aberrations due to environmental manipulation is too much compared to the smart pill bottles that are using infrared and low cell sensors. They are easily damaged or they are very highly expensive, which cannot be used by everyone. Some are very complex and can be easily removed. Hence, it's too complex to use it for a daily person or a person who is not with all the knowledge about the technology that is being used in it. So the purpose of our particular project is to provide an efficient and to improve efficient lifestyle for the patient so that they have a less restricting lifestyle and they can indulge in other things and not worry about medicine taking and all of that. So the scope for our project is basically to target the people who are going to be taking these medicines on a daily basis, which usually entails people who are terminally ill or have chronic diseases and older people who need to take their vitamins and other medications to keep their parameters in check. But we also want to provide a real-time analysis of how the patient is taking the medicine, and in accordance to that, the medical professionals can provide their treatment or change their treatment so that it can benefit the patient. So some of the works that we have referenced in order to understand the different sensors and different methodologies and networks that were used in order to use the other existing papers according to how we can use the pill bottle we have referenced here. And using these, we got an idea of what all we can use and what all we can implement and increase the horizon of how many things we can implement using this particular pill bottle. So coming to the proposed system and the architecture here, as you can see that we've given an architecture diagram in which over here we have the ultrasonic ranger, which is going to be connected to the node MCU, and both of them are going to be attached to the bottle. And through the Wi-Fi, that is Wi-Fi module or to the node MCU, which is already included, it's going to send these data that it's going to take to the cloud, where the cloud is then going to process it. And since the code runs in loop on the node MCU, it is going to continuously be sending the values at a certain time interval. So after the values are processed on the cloud, they are going to send it to the application interface, which we are going to be using as our front end with API and integrate the cloud and the application interface using the APIs that are provided by the cloud. So the benefits of our proposed system is going to be that it's going to be cost effective compared to the other models because the ultrasonic ranger is way cheaper compared to the other sensors that are available in the market at the moment. It is going to be sturdy and robust in strength since the ultrasonic ranger has its transceiver and its receiver on the same PCB board, which can be attached to the top of the bottle and does not need to be adjusted in any sort of way once it's connected. There is going to be less hardware density since we are only having the node MCU and the ultrasonic sensor that needs to be connected, which can be connected very less intrusively and will have a reduced and compact size. The algorithm or the code that we're going to be using for this particular project is going to be also much more compact and much more easier to understand and to implement. But when we come to trade-off between the existing and the proposed values, when we talk about the infrared sensors and the load cell sensors, we know that they provide a much better accuracy and precision in terms of values. But since here we do not need precision and accuracy in terms of values, we can provide the accurate value of when the bottle is being opened and closed and the count according to that in the proposed system. And the complexity of connections when it comes to that, the complexity of connections in the existing systems is much more complex since they need to be connected in multiple ways to provide a much more stable connection, whereas for the proposed system, we do not need to do so. So the hardware and the software that we've used in this particular project will be the Nciem Wi-Fi module that we've been using. It's also known as the ESP8266 Wi-Fi module. We have the ultrasonic ranger, which is going to help us find the distance between the top of the bottle and the bottom of the bottle to decide when the bottle is being opened and closed. We have the OLED display to give a physical appearance, physical display at the time of opening and closing the bottle to help us understand how many pills are inside and how many when the bottle is being opened and closed. And then we have the USB B type cable, which is going to help us provide power to the entire device. The software, we are going to be using the Arduino IDE to code the particular algorithm and update it to the node MCU. We have the Nciem cloud where all of the data is going to be stored and all of the data is going to be run. Then we are going to be using web programming languages and other front-end languages to make our application interface, which we are going to be integrating with our Nciem cloud. So when we come to the implementation of the project, we divided it into three particular phases. One is the first one is acquiring the values, where we are going to be getting the sensor values from the ultrasonic ranger, and which is going to be sent to the node MCU, which will then send the data to the cloud via the Wi-Fi. So for finding out the distance and finding out when the bottle is going to be opened and closed, we are first going to decipher the distance from the top of the bottle to the bottom of the bottle, and we are going to create a threshold value above which then the bottle we're going to assume that the bottle is closed, and below which we're going to assume that the bottle is closed. So then these values are going to be sent to the cloud, where we are going to decipher when the bottle was opened and closed. So since on the Nciem cloud we only have the data being represented in charts and other design methods, we are going to be using the lamp indicator to indicate when the bottle is being opened and closed, and we're going to have a numeric display for the number of pills inside the bottle. And the third part is the display of the values. We're going to be displaying the values by connecting by using the API key that is going to be provided by our Nciem cloud, and we're going to be integrating it to our front-end interface so that we understand, so that it is easier for the caretaker or the doctor to log in and understand the patient's habit of taking the pills. So coming to the results, we have two kinds of outputs that we have to take into consideration. One is the distance that is going to decipher when the bottle is going to be opened and closed. The second is the count of the number of pills that are inside the bottle. So as I said before that since on the cloud the data is only represented through graphs and numeric counts, we are going to be representing it through a lamp indicator and other graph values to understand. But the data represented on the front end is going to be in a table format, which is going to help us log, which is going to help us understand when the pill was taken according to the time that it was taken off. So coming to the conclusion, we all know that IoT and its devices has a very positive impact on the field of medicine and medicare. And in the future, we can see that it will have much more we're going to see that it is going to have a much bigger impact, and it has potential to provide so much assistance to the medicine and to the field of medicine and to medical professionals. We see that many more assistive devices have come about to help the medical professionals out and to give them assistance in the same. So the paper that we have presented right now, we have just presented a device, a proposed device that is going to offer a much cheaper and it's going to be more compact and has better model usage. So the whole paper's point is to provide a non-restrictive method for caring for patients and to provide better care for patients in terms of hospice and hospital care. So with that, I'm going to end our presentation. Thank you. I will if there are any questions. Yes, sir.
Thank you, Partha sir. Yeah, actually, Yeah, I have gone through the presentation. It's the concept-wise, yes, it's useful. Means engineering part somehow. I think you people are better judges for that. So I don't want to comment on that. But yes, it is particularly try to see that means which patients need these type of solutions. That is means yes, you have already mentioned there terminally ill patients and means particularly, but there are even many patients who means
Yes,
yeah,
yes,
there is a,
people who need to take medications on a daily
yes,
basis. So there are
are,
multiple people.
yeah, what happened that because of Alzheimer's and Parkinsonism,
Yes,
people
sir.
have difficulty in taking the medicines. Not only
Yes,
that,
sir.
there are very young generation is passing through the epidemic of means thyroid disorder, diabetes, and hypertension. So stress disorders. So they also have to take medicines. Sometimes it gets repeated, and for that they have to keep all that box of 7 days or something like that. So if there is a monitoring system from what you have shown up, and if somebody can see on the means their mobile screen whether today's dose has been taken once, so nobody will yeah, what happens many times even diabetic patients, they have so many drugs to take, they can forget because already they are say 70, 75 years, 80 years old. So even if they do not have any means Alzheimer or any such type of disorder, still they can forget. So in these patients particularly, such innovations can help a lot. So I think a good idea, practical implementation will depend whether it can be means what you can say the collaborated with the screen display on the mobile, whether you have already consumed this particular dose of today or something like that. If it can be done, I think that will be a great help to the medical community.
Yes, we are working on that application interface for the businesses. Thank you.
Yeah, so yeah, yeah, we means
Yeah, I need the justification of the efficacy and efficiency.
Sorry, sir, I couldn't get you.
Efficacy of your proposed system.
So till now we haven't able to get the efficacy till now since we are still trying it on people. Uh, our project isn't entirely complete yet. We are trying to include some more implementations and functionalities to it. So we haven't really got to the efficacy part yet.
How
yeah,
would it be the product if it comes out a product? How it should be? It's
Uh,
like robot or
so right now we're trying to. So it's on. Can you not see me? Can you see me now, sir? Sorry, sir, I couldn't get what you said.
how the product should be. It's a kind of
So I can show you a picture of what we have for now. Just give me a second.
it's a kind of robot or
So it's a pill bottle. So
mobile.
till now, can you see the bottle?
Okay.
So we have the ultrasonic ranger which is on the top of the bottle, and we have the node MCU connected onto the back.
Okay.
And
That's all. Thank you.
yes. Yes.
yeah, there are means, as Robin sir has rightly said, there are means clinical data efficacy and efficiency guidelines on clinical trial
Yes.
registry. Yeah,
Yes.
it means even for the any instrument also the same clinical trial registry is there, and there are separate guidelines for that. So
Yes.
kindly go through that before actually once the prototype is ready, so that otherwise means you cannot move further if those guidelines are not followed. Yeah, kindly
Yes.
take note of this. Yeah.
Yes. Thank you, sir. Thank you, sir.
I'm here, sir. Hello. Oh, here you go. Okay, 1 second. Yeah, is my screen visible? Okay. So, yes. Yes.
Yes, sir. Sir, I think 3 groups.
Yes, thank you. Okay, so good morning. Sorry, good evening. Our paper is about an augmented reality greenhouse to demonstrate game-based learning. So this is presented by Swati, my partner, and me. And we've done this under the guidance of Professor R. Rajkumar, sir. So this presentation will be going over the following subjects. So when we get started with what augmented reality is. So augmented reality is this idea of creating like a computer is going to augment some sort of information onto the real world. This is usually done in a visual manner. So we take some sort of visual 3D model and we place it in the real life, in the real world, and it's viewable through some camera setup. AR has seen a lot of growth in the past few years, and it's still growing. So here are some of the market research that we've done. We've seen that there's a great increase in the amount of the user base and the investments into augmented reality technology. So getting into the abstract of our research, we propose a mobile-based augmented reality system that provides an immersive simulation of a portable sort of gardening experience. So the user of this application will be able to explore their garden, build these pots, terrarias, and they'll be able to nurture and maintain various plants. And they have an end-to-end simulation of gardening. The benefits are that this is completely portable and it's safe. So it allows users to experiment and play with, even exotic plants and the like. So this is a novel approach in experimental learning. We are also trying to process a comparison between traditional e-learning and our proposed work. So we evaluate and explore concepts of game-based learning, user feedback, retention, and we aim to inculcate interest in gardening and the concepts of gardening, especially among the younger user base. Swati?
Let us proceed with the literature survey. I'll give a short overview of the papers we have surveyed. So most of the papers have inculcated augmented reality and game-based learning in English vocabulary, and there's a biodiversity science museum that uses it. And then there is also something to do with 2D and 3D shapes. And there are augmented whiteboards that are present and piano lessons that can be taught using AR. We've also done a survey on different type of 3D interactions, and we're trying to find a novel way to inculcate all these 3D interactions in a useful and productive way for gardening. So the next slide, please. So our next, we are going to describe the objectives. So our objectives is, so in all the papers that we have surveyed till now, there is a misconception that AR cannot be fully immersive, that only VR can do. So we have found a novel approach of using an AR portal that basically we will explain in the future slides how it has a fully immersive gardening experience. So our next objective would be to optimize the performance on low-end devices as well. So that you can have a simple hardware that doesn't cost a lot. Just your mobile with a normal hardware can augment portals. And we, like Vivek said, we plan on doing a comparative study. And since we want to have the best practices in object-oriented programming and database design when we're going forward with it, so you can expand and add more plans in the future. And like Vivek mentioned again, we are evaluating different concepts and want to inculcate this for a younger base. So yes. Okay. So the application design, next is application design. So here I would like to elaborate more on what the portal is. So as you can see from the image, it will once the mapping happens from your mobile, a portal will materialize. So you can walk through this portal and you will see a completely different environment and you can walk out of it. So it'll be sort of like a door that you can walk in and out of. So that's what we have done. And once they enter, they should be able to look at the portal into the real world. So this is going to be the setup of where we can place the different gardening items, the tools and the plants. So next, we would like to explain the different phases that we plan for this plant. We're going to focus on a particular plant to go through. So the first planning phase will be we can educate the users on the different types of soil that are being used for the particular plant, the tools that need to be used, and the user learns the various requirements, the conditions, and how this particular plant has to grow. Like when they're setting the plant up, all this information will be presented to them. So the next phase is the growth phase. So so before that, this is how the portal will look, how the room from the inside will look. But we will have a demonstration to show how it look, get a clearer idea. So as you can see, there are different plants and pots over here. So moving on, the next phase that we're going to go through is the growth phase. Here we will show the user, we will show like the day by day growth of how the plant looks, how it grows from the roots to the shoots and how it becomes bigger and bigger every day, and how basically the user's actions are recorded and scored on their daily activity to nurture that plant. At this stage, the user is made aware of how the plant grows, the patterns, and the routines of daily maintenance. So the next phase that we want to go through, so before that, this is the example of the different stages of a particular plant that we have chosen. So for the next phase is the maintenance phase. Here we would like to educate the user on the pruning and the weeding and taking the pesticides and all that. We would like to educate them on how to maintain the plant for it to last longer and to nurture and procreate. So they are now open to restarting the life cycle with a different plant since they're educated on a particular plant. So these are the main three phases that we would like to cover in the plant growth life cycle.
Okay, so thank you, Swati. So we have some screenshots here about how the maintenance is implemented. And here is how our idea is for imparting some sort of information that isn't conveyed implicitly by the application itself. So let's get into the implementation part. This can get a little technical. So in order to optimize our, we want to get this application ready as soon as possible and out to reach as far user base as possible. And so it was sort of a no-brainer that we use the Unity engine and the accompanying plugin for AI Foundation. So we also have a backend, a server that is hosted on Heroku, which is written in Java and using the Spring Boot framework. And our data is stored in Postgres. So here is an architecture diagram, sort of overview of how augmented reality applications are processed. So the user, starting from the left, a user interacts with the interface of the application, which registers inputs. The inputs can be of types device orientation and hand gestures and things like that, which is then processed by the front-end system, the engine, and all of these informations are processed. This processing is informed by the information that is stored in the database, and then the output is evaluated and sent back to the interface for the user to consume. So Powering all of this at the back, foundationally, we have the Unity engine and the AR Foundation toolkit. So here is a database diagram, an entity relationship diagram of sorts. So we have, the idea is that a user can log in and can create an account and log in. They can grow multiple plants. Each plant can be of any species, and users can create any actions. An action would be watering a plant or pruning a plant, adding a plant, and maintaining it, and so on. And these sessions are used for tracking how far the plant has grown. So, so getting to the portal's implementation. So we use the portal area as a stencil mask, and we tell the engine to draw what's behind the stencil mask. Once the camera passes through the mask, we flip the behavior, tell it to render everything. And when we exit it, it again draws only what's through the mask. So you can observe specifically in this clip that when the camera is actually outside, you cannot see the walls, or you cannot see through the walls into the room. But once you enter, you are able to see through the walls and the walls and the room. Okay, so this is another interesting issue that we tackled, where we had to place an object in augmented reality through the phone. So what we do is we cast a ray down from the phone, and if it collides with a plane, we register that point and calculate the normal on that plane. And then we rotate this, we get what's called a transform structure that contains position rotation. We rotate this to point towards the user at all times. And that's, you'll be seeing later how we use this to actually place the plants in the room. Swati.
Yes. So now we get to the preliminary user research that we have done. So first we did gather the feedback from like an application like feedback. We gathered that, we made improvisations, after which we proceeded with a comparative study between traditional e-learning and e-learning using our application. So we got participants, we divided them into two groups, and group A learned about the growth of a fern. The plant that we chose for the experiment was a fern, and we sped up the process in order for them to understand clearly as to what is going on in this e-learning process. So we gave them 2 hours. So group A learned using a slide deck, and group B used our AR application for learning. So go to the next slide, please. So now the research results, we had different sections of assessments that we wanted to go ahead with. The first section had questions that were about the fern and about the life cycle of the fern and about what kind of plants were used when you were going through it. So as you can see, the group B's average score was way better than group A's, and group B, that is the group that used our app, was able to remember the small details about the fern, and group B also found it easier to answer our subjective questions in the right technical terminologies compared to group A. So next we went to a general feedback about the quality of our application. So we used the Likert scale, and we asked about the different emotions that they were feeling during the application. And to no surprise, the group that used AR found it more exciting and inspiring and pleased with the experience, compared to studying from a PPT made them find it more boring and annoying. And as a result, the overall satisfaction for the group that used AR was more compared to the group that used the slide deck. So finally, we had a miscellaneous feedback section where we asked them to talk about user satisfaction and also to give a feedback about the application and the PPT and how to change things. So here we asked like general feedback about the interest in other subjects and interest in other plants, and if they would share it to their peers. And group B showed a lot of enthusiasm in using ARs, and especially having a portal, because that was something novel that we had done. So they found it interesting to use all this to learn about the gardening and the plant growing experience. Go to the next slide, please. So the miscellaneous feedback, we got the app rating as well. It was around 8.83. And we asked like a general about how they found this entire session to be. And the group that used the presentation did tell that it was hard for them to remember it, but since they visualized it in group B, it was easier for them to respond to questions and also re-evaluate how they felt about the entire experience. So the research results overall showed a positive inclination towards using AR for learning something new. So go to the next slide, please.
Okay. So the future scope of this project, we include, we want to conduct a little more research to solidify our hypothesis. We also want to improve the user experience by adding more species and more tools and more interactions for them to keep coming back to the application. We also have, since this idea of game-based learning is really amplified by adding a social aspect to it, we want to have a feature like a friend system where you can visit somebody's garden, their greenhouse, and you can share them and take photos and videos and things like that. So we want to include that kind of aspect to the application. We also want to increase the information presentation rate so that we can provide more information, more high quality information regarding the plants and the gardening procedures and more. So here we have some images about our application. We have login and we have some information and plants that are growing. This is actually taken on, I believe, Swati's terrace. So yeah, we're pretty proud of this one. We have a good shot of the background of the terrace, and we have the insides of the greenhouse. So we also have a video. If we have time, I can skip through it. Please interrupt me if I'm crossing the time, but this is the video. This we'll skip through it. It'll take like 40 seconds.
Yes, sir. We'll just fast forward it to show the.
So here is the idea how we place the place the room, and then the room is visible. This is shot in my parking lot. So the player can just enter the room, and then they are inside the room. And so later on, this is how we place the plant using the raycast technique. And then we approach the plant, and we can check information about it, and we even water it. I believe the tracking was a little difficult at this point.
So here we wanted to demonstrate the different growth stages and what happens as a result to every action you do. You're rewarded with seeing the plant grow and improve as you continue to water it every day. So this is the final stage of a overgrown plant. So here, this is just an example of the information we give on how to grow this particular plant and what is happening. And then we allow the user to perform the action of actually pruning the plant. So it reverts to a normal stage of growth.
So these are the interactions that we have. And then we can place a whole bunch of plants if we want. So that is sort of, yeah, the idea of the application so far. So these are the references that we have. And that concludes our presentation. We just, before we get into questions, I'd like to thank the panel, the organizing committee, and our guide, Rajkumar sir, SRM University, and the Department of Computer Science, and all the audience for your time and patience. Thank you. So if there are any questions, get into it. Thank you, sir. Yes. So. Yes. No, sir. So the AR experience is not locked to any location, and that's what we see that as a benefit. So even if you decide to go on like a 1 month tour abroad, you can take your garden with you, which is, yeah. Yes, sir.
Yes.
Yes, sir. I play it myself. Hmm. Yes, sir.
Sure, sir.
Sir, sounds interesting. We'll get back to you on that, sir. So, any other questions from the panel?
It's very nice work, and then whatever I want to say already been communicated by. Good work. Continue to do.
Sir. Thank you, sir. Yes, thank you. Thank you all.
Yes, sir. Yes, sir. Sir, Rutuja Jadhav. Sir, I am present.
Sir, I am his teammate, but she is presenting. So,
Uh, is my screen is visible?
my name is
Sir,
Kalyani
Kalyani
Katte.
Katte.
Kalyani
Kalyani
Katte.
Katte. Wireless tracker for warehouse management. Yes, sir. So, my name is Rutuja Jadhav, and we are doing the project under the guidance of the Pramod Kanjarkar, sir. So, our problem statement is to design the system of the wireless tracker for the warehouse management. So, firstly, let's think for the company like Amazon and Flipkart. They provide the delivery service to us at home. So, what happens exactly with the stockroom of such companies is there are many products to keep. Uh, there are many products which are kept in so many racks. So, for example, if one labor kept the Samsung phone, let's see the example of the Samsung phone box. So if one labor kept the Samsung phone in the box in the particular rack, and oftentimes the worker forget where was that Samsung phone box. So but when the customer actually order the Samsung phone, then the company have to provide that Samsung phone to the customer as soon as possible. But at that time company don't get that Samsung phone box quickly at that time. So to access the product box easily in the warehouse and to provide the better customer service, the company need to this solution for the faster product delivery. So this is the methodology of our project. So we are designing the smart track solution for this problem. So we are making the system in which the labor will keep the box in the specific smart track, having one keyboard for entering the product number and rack number at that time and at that location. So and after the when company want that particular box after some period, then worker have to just search that product number in the search field of the server, which is present in our Android phone. So after searching the product number in the Android, worker will know the exact location and the exact track number of the product in the warehouse. So don't need to waste our time for finding that product. So in this way, we can easily monitor and monitor the mobility and storage of the product in that particular warehouse. So this is the block diagram of our project. In this, this is a intelligent smart rack having the keyboard, microcontroller unit, display, and RF transmitter. When we give the input to the smart rack, which will be the numerical input, and we will enter the input for the product and the rack number. So when we have to access that the product, the input which we have entered in the rack will save in the database in the software system. So whenever we have to access that product, we will search that product number and the rack number in the software, in the server, in the search field in our mobile. So we will make the app for this, and we can easily access the product which we have kept before, and in this way company can easily find and easily monitor the mobility of each product in its rack in real time. So do not need to take much efforts, and do not need to waste our time for searching the product in warehouse. So this was a simple project idea, sir.
Means we are working on it. So this is the project problem statement which were given by our guide. So we are working on it.
This is the industrial problem statement. Yes, sir. Sir, there will be the Wi-Fi module for this and RF transmitter, through which we will give the connections from the rack system to the software system. Yes, sir.
All the best. All the best. It should come out as good prototype and product.
Yes, sir.
Yes, sir.
Thank you, sir.
We are working on it.
Thank you, sir.
We are left, sir.
Yes, sir. From VIT, sir. Our group is left.
From
Just a
SRM
second.
also we are left, sir.
So this is Patangi Nagakishore. Yeah. Yes.
Okay, sir.
Yes.
Yeah, so am I audible, Dhananjay?
Yes, you are right.
Yeah. So good afternoon, all. I'm Ram Wagmare, and our topic for this project is infrastructure monitoring by UAV. So the civil infrastructures, such as building dams and uh, various roads, are due to shrinkage and aging. Some concrete tracks are uh, gates as a byproduct. So that's a serious issue that may result in some serious hazards or may also result in fatality. So the traditional methods for building inspections are like the engineer comes, he evaluates the building, he monitors all the data and then evaluates. And the problem over there might be the decision may have precision or may not. So what we are trying to do in this project is that we are using a UAV that which will monitor the building, and it will capture some of the images or footages, and upon that we will do image processing, and we have trained the model, and it will show the results like how much percentage of crack it has or not, or the severity of cracks. So Dhananjay, you can proceed now.
Yeah, sir.
So the motivation behind to choose this project, that as already Ram explained that previously, the inspection and monitoring of building is more difficult. Engineers will inspect that building and it will take some more time and it is costly. But by using UAV, it reduces our time and it reduces our cost, and it will give instant result as we want, and it will also predict the lifespan of that building. So our project has a project feature is we will capturing image from UAV. We will analyze that image and we will detect whether it has a crack or not. And along with crack detection, we will go for rust detection, which will happen on the steel bridges. Yeah, Puneet. So
Yeah. Yes, thank you, Dhananjay. So, good afternoon, all. So, as Dhananjay and Ram explained about the project motivation and its necessity, so as for scope, it is very necessary as a surveillance of the civil infrastructures, as many of the bridges while constructing occurs a crack. So many of the engineers, it is not visible from downside. So we are using a UAV which will take images far more from which were not visible to the engineers. So we are and the crack detection and the orientation detection will be done, and moreover with an rush detection and intensity localization also be done with that. So next slide, Dhananjay. Hello. Yeah, as you can see here, it's a simple block diagram. As furthermore we go forward in the slides, each block will be explained in deeply. So first of all, there is a drone which where we bought uh, uh, ready-made, as it has a dual camera and 720p HD Wi-Fi FPV with a secondary camera to sense its surrounding, to assess six axis gyro for next level stability and positioning holding. So we will take some images with the drone of the cracks, and we will feed these images to the computer, and this will be analyzed by an algorithm which is made by us, and the crack intensity will be displayed on the graphical user interface, which is GUI, which is also made by us. Furthermore, will be all these specifications will be displayed on the GUI as well. So next slide, Dhananjay. So these were the softwares which were used, like Google Colab to train our model, Jupyter for coding, and Irfan View 64. And Goska is an application which will install in the mobile to take capture the images of the crack over the bridges or the building. Next slide. So these are the some specifications of the drone which we are using in our project. So Ashish.
So, as my previous friends, as my friends tried to explain what basically we are trying to do, I would like to elaborate a bit on that point, and then further I would like to continue towards my part, that is the algorithm. So basically, while developing this project, we were thinking various methods. We consider various previous methods used for this particular crack detection problem. Many of them were using a few bots, rovers, land climbers, but most of them was having a issue with them, that the mobility in most of those devices were not as good as required, and the precision was also not that good. So what we tried to do was, we thought that instead of going by these methods, we should use something more advanced. That is, instead of going by land way, where it was more difficult to maintain the stability, maintain the stability or flexibility of the location that we can reach. We went for drone. And for the further processing purpose, we tried to develop a ML based and a simple OpenCV based algorithm, so that we can sort out the images, make the sequences, and then try to give a complete data to the user, so that the whole process that people do when trying to do the inspection of a building would be done in matter of few minutes, hours, instead of the whole process that it takes few days or something. So moving on to our algorithm part, as Puneet explained about the basic block diagram of our project, I would like to give insight about algorithm part of our project. Our project's main aim was detecting the crack area, patches from the building, and rusted area from the bridges. So as you can see here, it mainly follows the following sequences. At start, what we did was we captured images, video footages with the help of drone, which was fed into the computer for further processing, where we used a CNN based model for classifying the image, whether it was cracked or not. This CNN based model was trained on 40,000, more than 40,000 images on mobile net architecture. Actually, we before mobile net architecture, we tried to develop we tried to build some of our own architectures, but the result was not as good. So what we thought was, instead of trying to develop this new architecture, we would like to go with the efficient and one of the most portable CNN architecture that is used in various real world applications. So before going deep into why further aspects, I would first like to give some light on this mobile net architecture. So mobile net primarily uses depth-wise separable convolution in place of standard convolution. This is the point which helps the mobile net architecture to be lighter than the other model. The input size image for this particular model was the required input size image was 224 by 224 by 3. So mobile net models are built on depth-wise separable convolution layer. Each depth-wise separable convolutional layer consists of depth-wise convolution as well as point-wise convolutional layer. Including all this depth-wise and point-wise convolutional layer as separate, counting them as separate layer, mobile net has 28 architectures. As this was a light and way too much efficient model architecture, so we'll use mobile net as our architecture in CNN. So once we had determined with the help of the CNN model that image has a cracked portion on CNN model, we further tried to derive numerical inferences so as to procure data for further analysis in tracking the record of health of the structure. For this purpose, next slide. For this purpose, what we did was we use basic principle of image processing analysis, such as edge detection, noise block removal, and then finally binarization of the sequences, so that we can calculate numerical references from the images based on this percentage analysis. Now further, whenever we after we have done the basic health monitoring of this system, we will be getting a data based on the whatever the what was the percentage of crack. This is all done with respect to our frame, so with reference to image frame. So basically what we are going to get is the intensity of the crack, how much is the intensity of the crack of various different locations, which will be captured by our, the location that would be covered in our footage of drone. Then further we will be analyzing this data and sorting it in what we can say a document, so that we can use this reference, what we can say, the health of this particular infrastructure as a reference for whenever we will be further doing another health checkup of this infrastructure, and we can compare and consider how much degradation of this particular building was done. And further the government or whatever institute or the thing which is trying to go for the infrastructure surveillance can take action as per the health report. Now I would like my friend Harshal to proceed on towards the rust detection and further more parts.
Yes, good afternoon, everyone. As my Ashish explained about the CNN algorithm, so after we classify the image as either cracked or not cracked, so we take the cracked image and then apply a certain algorithm to convert that image into a binary image in which the white pixels will represent the crack and the rest all will be converted into black. So the flow of the algorithm is that we take that correct image, the classified correct image, then we apply Sobolev detection, and then we apply thresholding and binarize that image, and then we use blob removal to remove the noise. So as shown in the previous slide, we get an image where the white pixel will be representing the cracks. So like to calculate the percentage of crack in that particular image, we counted the number of white pixels divided by the total area of the pixel. So this will give us a rough value of how much, like what is the intensity of that particular crack, and then we further classify that into small, medium, or large sized crack. So this is the basic algorithm for the crack detection. And in the next slide, similarly, we also did this for rust detection. Next slide, Dhananjay. Yeah, so in the rust detection, we similarly created a CNN model, and we had a data set of rusted and non-rusted images. So once we classify these image as a rusted image, we then apply this thresholding to convert that image into as shown on the right side. Like we get only the rusted part, rest all will be converted into black. So similarly over here, we calculate the intensity factor that we calculate the number of pixels which are in that range of color of rust divided by the total number of pixels, and this will give us a rough estimate of how much rust is there in that particular image. So similarly, we will then classify that into small and large sized rust. So this is the basic algorithm of a project. Next slide. Yeah, so these are the references that we refer. Thank you.
Sir, so as Harshal also tried to explain, sir, what we are doing is we will be doing binarization and then counting the pixels. This would be with reference to image frame, the particular image that we have captured. Then, yes, yes. Yes, sir. So I'm Ashish Jaiswal from VIT. We have done this project under the guidance of Pramod Kanzarkar, sir. So as Herschel tried to explain, sir. So basically, this in while the for process of this particular what we can say calculation of the crack, we first we what we can say but with the help of edge detection technique, we tried to find out the edges. Then we did the binarization of the sequence. Then after the binarization, we calculated the white pixels. That is, after the binarization, those edges were converted into white pixels, as it was shown in PPT. And then we calculated those white pixels, and then we did an average based on these white pixels and the remaining black pixels. And we tried to calculate the intensity based on this particular. This intensity was relative to that image, sir. Sorry, sir.
Sir, it's a Sobel edge detection algorithm for edge detection purpose.
Yeah, I think I've taken a project for the image processing. Am I right? The case study data set you have taken for the crack. Am I right?
Yes, sir.
Okay. So you have taken a very good case study, but you are not anything you are addressing for curing.
Yes, sir.
Curing the crack.
As in for
you can go through some research on the automatic curing of the cracks and enhance. If you enhance your problem, then definitely it will reach many people.
Yes, sir, sure.
Okay, so let us research on emerging research of curing some alkali to grow up some alkali so that it is helps to cure the or fill the crack. Okay.
Yes, sir.
Thank you.
Yes, sir. Sir, it is 720p HD camera, sir. Yes, sir. Yes, sir. It's basic. Yes, sir. Thank you,
Sir,
sir.
Hello, sir. Sir, am I audible? Currently, sir. Me, myself, and so we are two people currently. Me, myself, Siddhant Mishra, and Ayushman Mishra. So, is my screen visible? So, sir, here we are making a project on flood severity prediction with IoT and assembled machine learning. Hello there. The title of the project is Flood Severity Prediction with IoT and Assembled Machine Learning. This project will be done by two first Siddhant Mishra, that is me, and Ayushman Mishra. And this project has been guided under Subhash Ansar. As we all know, flood is a natural disaster phenomena which causes severe losses in terms of goods, properties, and most importantly, human and animal lives. Though it can't be avoided, it can be the area can be cleared under perfect warning if an alert mechanism. So in this research, we use multi-sensor data which is collected via IoT sensors on river and seabeds. They collect this data about humidity, water level, and river sea level, and then the data has been compared with using machine learning algorithms, which compare the data with the existing data sample which is collected during previous occurred floods. After comparing the data, if the data is found to be severe enough, then the mechanism of the system will measure as soon as possible. Hence, the conclusion of this paper could be described as
There's a lot of noise and your voice is not clear.
Pardon, sir, I didn't get you. Hello, excuse me, pardon, sir.
Now it's better.
The main objective of this project is to predict flood severity before it happening and minimize the loss caused due to flooding. The prediction of flood can help us reduce its impact by
No, I'm not able to hear you. What about sir, Patra, sir?
sorry, sir. Was I not audible? Sir, was it not? Oh, so wait, sir. Let me just increase the
Now it's
voice.
okay. Now it's okay.
The main objective of this project is to predict flood severity before it happening and sir, actually, what we are presenting, it's pre-recorded, sir. I think that's why it's a happening problem. Okay, sir, no problem. Yes, yes, sir, yes, sir, I can just present it. So, the main objective of our project is to, sir, collect data from river beds using IoT sensors, so that we can apply on machine learning algorithms, so that we can predict the severity of the flood and warn the people around that flood-prone area before the flood occurs. So basically, we will be using the previous year recorded data of any previous occurred floods, and we will compare the data to the currently acquired data which will we get from the IoT sensors. And so by comparing and using ML algorithms, we will predict the severity of the flood. So for this we are using the main sensor HCSR04 sensor, IoT sensor based sensor. This will detect the water level, humidity, and water density, which are the main key features required for predicting the flood severity. And so then we will use Wi-Fi module for alert mechanism, so that any appliance with the feature of internet can get the notification and be aware of flood coming or occurring. So this is the block diagram. As we can see, the data will be collected from beaches and seashores, and it will be collected via the sensor, and it will be stored using Arduino and ML. Arduino, it will be stored and taken to the computer, where we will use ML algorithms. And after using ML algorithms, we'll predict the severity of the flood, and then we will using Wi-Fi module. We will transmit if the severity is if the flood is very severe, we will transfer alert mechanism. So experimental setup will be explained by my partner.
So basically, we have used two machine learning algorithms to test on it. One is linear regression, and then is the vector support vector machine. So basically, in linear regression, we have found that it is the value which we previously got from the pre-recorded flood. We have used the Kerala dataset. So in that, the pre-recorded value, what we got to the truth value, this is more like the values are more near in linear regression, whereas there is a bit of difference you can see in the graph in support vector machine. So we find linear regression to be more useful. Basically, what we are doing is we are basically getting the data from the sensor, and our IoT system is used to see if the flood occurs, and our machine learning system basically predicts how severe the flood is if it occurs. And then the alert mechanism is connected to the IoT system. So this alert mechanism, based on the severity, it will be used to alert, and then a connection between IoT mechanism and our linear regression model and support vector model. So these are basically present in the computer. So they are basically transmitting data through the Wi-Fi module or the connection directly through the Arduino.
Collection of data from IoT platforms and sensors, and the flood severity will be predicted. So the performance evaluation.
No, for testing, we are generally right now we are using a bucket and you're doing that. We are not like right now we are not doing, this is a demo model, so that's why. After that, when we update like for C-source and all, we have to use a lot of sensor. Only one sensor won't do. So
No, so actually I was sitting near a table fan. I have shut it down now. Okay, so the performance evaluations will be based on mostly on linear regression, as we tried support vector, but it did not gave us a good accuracy. So we will be mostly using now linear regression. And so the main idea behind this project is to integrate both the machine learning algorithms and IoT. And as we search and for other projects regarding this topic, we found that many such projects are in development phase or in testing phase, but mostly are manually operated and require somewhat involvement of a human factor. But the proposed model which we are making is entirely automatic. It doesn't require a human factor, so human error will be eliminated in this process, and it will be fully automatic. And so here are the few of the references that we took. Thank you also. So any questions? Any questions, sir? Okay, sir. Thank you, sir.
Yes, sir.
Potter, sir, I have one request. Yeah, I have another meeting by 5:30. Okay. Okay. Thank you.
Yeah.
I have posted one link on sustainable development and encourage the participants to go through it. So where you have a lot of problems, even sustainable development goals recommended by United Kingdom. Its presentation is based on it. Thank you. Thank you so much. Thank you, sir. Thank you. Thank you so much. Thank you, Dr. Atul, sir. Thank you. Hope we will meet in some other occasion. Definitely. Always. Yes, sir. Thank you. Thank you. Congratulations for successfully conducting this conference. Thank you, sir. Thank you.
Yeah. Yes, sir. Can I start it? Yes, sir. Good evening, one and all. And this is Kishore. I'm from SRM University. And my project is augmented reality based shopping experience using this IoT. And under the guidance of Mr. Rajkumar sir at SRM University, he's an assistant professor. And the basic abstract of this is in the physical store, customers are overloaded with the unstructured product information, including ingredients, the product nutrients, carbohydrates, and the product labels, and the information about the project cost and the location where the product is in the supermarket. It will be very uh, it will be very hard to find the product in the supermarket when the customer enters the supermarket. So this is an app where we can know the product location where it is present in the supermarket by using the IoT, and we have used the BLE icons and the geolocation and the geofencing methods also in this. And um, the output of uh, uh, this project is to visualize the customer the product list in the supermarket, and the customer can choose the product and he can move further of this. And the existing system which we have referred till now is the customers when they are searching for the product, and it will be taking a lot of time, and the product which is inside the shopping mall, like they need to know whether the product is available inside the shopping mall or not. And in right now in the COVID situations also, the inside the shopping mall salesperson can't explain the each and every minute detail of the project because of this COVID issues. And um, and some of the limitations are the confusing signs inside the shopping mall, and the customer less customer friendly. and and what we are going to propose in this project is the augmented based shopping experience, and we'll be creating an app. The output is visualized by the customer in a visualized by the ranking product list inside the app, so that the customer can choose their best product inside the shopping mall. So advantages of this, when we implement this in the real life, the advantages are this to enhance the shopping, and we can do um, more friendly and more fastly also, and more interactive system with the customers. And the installation cost is also very manageable, and um, the position of the product is directly shown to the inside the customer's phone when we install this app. And the main challenge which we have faced in this is there are large when we enter inside the shopping market, the BLE icons packets RFA packets will be many number of signals will be generated, so that um, uh, we can't locate the customer where he is present. So uh, so we have using this localization algorithm and this BLE icons. We have like
we can locate the customer where he is present inside the shopping mall, so that he can, and when there will be guidance inside the app, so that how can he move to reach the product. And the some softwares which we are using is Unity 3D for building the whole augmented reality based uh, this one, and the Liforia cloud for the target images, and some of the packets inside the Unity. And the methodology, how we are going to implement here is, first we'll be scanning our first when we enter into the shopping mall, we'll be scanning, like if we open this app, the through the app camera, we need to we need to scan the target image, which means our product, the item. And using this, if we scan the item, it will be showing us some virtual buttons and a panel with all the information of this will be inside the panel. And we can, and if we, and there will be a button also, so that we will be um, navigate to the so and so product. And after, and the before when and for the buttons and and the functionality, we'll be using the C# scripts inside the. And one, and we have added the geofencing in our product because of the main use of this geofencing is to attract the more customers to our shopping mall. See, I'll be explaining you one example. So suppose we have installed the geofencing in some locality in our shopping mall with some radius of around 1 kilometer. So when a car passes or when a person passes into the geo fencing radius, he will be getting an notification that please visit our shopping mall. So, and we'll be even displaying the offers which we are there in the shopping mall, so that we can increase the sales for the business also using this geo fencing. And this is some of the outputs how we can be when we implement the project. and and under some results, when we install the IoT items like daily beer icons, we'll be getting the like we'll be getting a signal, so that we will be tracking the customer where he is, and how what are the preferences, what is the preferred product, and all the things. And one more, we are trying to add the we'll be trying to add this recommendation system inside our app also. So that I'll be like, when a customer took some milk packet, he will be recommended to take an biscuits or the like any sugar packets or any coffee powders like this. Will with the in our app only, it will be visible when the customer visit the product. So conclusion is, this is like, when we implement this in a real time, it will be very helpful for the customers. uh, and and it will be like, and inside the retail, inside the supermarket, the customers can find easily the products, they without any disturbances. And yeah, that's it. And these are some of the references. Yes. Yes, sir, I'm done with it. If there are any queries, you can ask. Yes, sir. Yes, sir. Yeah, thank you so much, sir. Thank you. Yes.
Hello, good afternoon, sir. This is Mohak Singh. I am working under Mr. R. Subhash sir only. Shall I share?
Yes, sir.
Sir, I think he left. Okay, sir. Sir, is the screen visible? Sir, is the screen visible?
Yes, yes.
Okay. Sir, are you able to see the PPT?
So, good evening. We are working under a guide, Mr. R. Subhash sir. Actually, we had a slot for yesterday. We opted for the recorded one, but we were told that now the session will be live only. So we are presenting now. So the title of our project is Prototype of an IoT-based wearable band for COVID-19 patients. Our domain is Internet of Things. Can you start with the presentation, Mohak? So this is an abstract. As we all know, nowadays during this pandemic, it is causing large number of deaths and still causing infection to people. Although the government all over the world has taken severe measurements to slow down the virus spreading, a lot of persons are still dying and many more are still in danger. But globally, the defections of the quarantine subjects are still rising, and still we are uh, seeing the second wave is again rising in India also. So if a person is COVID-19 positive, so we can the absconding quarantine subjects can infect more people, and which can makes the time to detection vital. So we are trying to make a prototype for a wearable band where subject will be more compliant towards healthcare routines restrictions. Thus, we will make the wearable band to detect the absconding people, keeping in mind the cost, global supply chain disruption, and COVID-19 quarantine duration, which the WHO recommends. It will also be bundled with a mobile application, so it will be reporting and tracking the absconding quarantine subjects in real time. So it is an economical solution that could benefit low-income regions to prevent the spread of COVID-19. So this is an introduction. As the WHO has already declared the novel coronavirus outbreak a global pandemic, countries are still getting affected immediately and urging the governments to take immediate control actions such as isolating highly affected regions. So along with the modern mobile application and cloud-based monitoring system, it will provide a scalable low-cost solution to detect subjects and track them in real time with the help of GSM module. So this is the literature survey. We did this survey for a many number of papers. Sir, do you want me to explain all the papers differently, or just you can have a look at them? Sir?
You can just, Mayank, you can just explain the title and the advantages.
Okay, so the following are the titles. We did a research survey. So now, novel coronavirus disease detection and diagnosis system using the IoT-based smart glasses. The advantages of this title is that the smart glasses can detect high body temperature in crowds and send the measured data to be displayed on the phone application. And the drawbacks are is the device along with a glass is necessary to get results from it. Another one is tracking infectious trajectories. The advantages of it that it helps the authorities to disinfect and high contamination sites in confined persons even if they have no apparent symptoms. The third one is the IoT band for tracking and absconding COVID-19 quarantine subjects. It contributes to a better quarantine system for the infected COVID-19 patients and helps in keeping the healthy environment. The fourth one is tracking contagion using the IoT technologies. The advantages of this one is that the proposed module will help in detect and tracking the contagious person. It will also keep the patient's data record for analysis and decision making using edge computing.
The fifth one is identification of highly suspected COVID-19 cases in social IoT. It suppresses its further spread by exploiting the social relationships between mobile devices in the SIoT to help control its propagation. The sixth one is IoT-based COVID-19 and other infectious disease contact tracing model. So it will be easy to identify the clusters or the contagion zones of infected contacts and help them deliver a notification for mass isolation while preserving the individual's personal location. The seventh one is three-layered decentralized IoT biometric architecture. This one is having the proposal as an over-the-edge computing over cloud computing architecture. The eighth one is fight against COVID-19 pandemic with 5G technologies. It provides the innovative solutions in the areas of telehealth, contact tracing, and education. The last one is, I guess, security threats to COVID-19 with the deep learning systems. The test results show that DL modules that do not consider defensive modules against adversarial disturbances will remain vulnerable to the attacks. I think we can skip this literature survey more. We can move forward. So this is a problem statement. As the patients affected with COVID-19 who are in home quarantine can break the quarantine rules and instructions, hence putting infected people at risk. The use of a wearable band prototype can help prevent patients from running away from hospitals and keep track of patients' activities. It would also keep uninfected people safe as we're in the middle of the global pandemic. Also, the people who are infected and are in home quarantine, they tend to disobey the quarantine rules. This also keeps a check on them. And the government and private hospitals officials can provide the band to those who come to the test for COVID-19 and are tested positive. So our main purpose of the project is to quarantine patients in a more organized way than the current way so as to minimize the spread of the virus. Mostly when people are in our home, they try to break the quarantine rules. So we'll be keeping a track on them with the help of our prototype, and the officials will always have a look at them. So we are trying to make a band more cheaper for low income areas and for mass production and for mass distribution to government and private hospitals and clinics. Mohak, next. Oh,
Hello,
you can carry on from here, Mohak. Yeah.
So this is the UML diagram, which shows the relationship between the doctors, the authorities, the patient, and the family. So once a patient gets tested and is positive for COVID, the authorities provide him or her with a wristband. The patient has to wear the IoT band, and it tracks the location of the patient. The family can communicate with the patient with the help of the mobile application, which shows the all the information like the live location of the patient. Next, we have the architecture diagram, which shows the whole architecture of the prototype. We have sensors, which include geolocation sensors and the oximeter. We have the microprocessor controller, which includes the Arduino board, ESP32 LED and Bluetooth. For display, we have the LCD screen. For social communication, we are providing alert notifications to the families. And then we have the data transfer, which will be done via Bluetooth to the mobile application. And then it will be displayed on the web application. And for USB, we have the power supply, battery charger, battery, and USB cable. This is the methodology which indicates the whole process that goes from start to end. So what happens is there is an infected patient. The infected patient goes for checkup and testing, and once tested positive, he or she will be provided with a band. So the band has three main functions. The first function is that it tracks the real-time location of the patient, and it happens in a four step. There are four steps for this process to occur. The first step is that there is a sensing node present in the band, which takes the live location of the patient. This information gathered is then sent to the patient's mobile via Bluetooth. The information includes the GPS coordinates of the patient, the state of the band, and the timestamp. And this information is then sent over to the main website, and the website shows the all the alerts and the location. The second function of the band is that it includes an oximeter, which will show the O2 levels present in the patient's blood. And the third function is that it will give alerts to the authorities in case the band is destroyed, or in case the patient leaves the quarantine zone, or in case the patient removes the band. These are the physical and sensing components. First, we have the oximeter, which will show the O2 levels of the patient. Second, we have the Arduino board, which will collect information from all the sensors and store it. Third, we have the USB cable, which connects the Arduino board to the computer. Then we have the step-down transformer, which will be used to convert the 230 volts AC to DC current. Then we have the bridge rectifier, which will be used to convert the 12-volt AC to 12-volt DC. It will convert it into an impure version. So for that, we use a capacitor, which will convert it into a pure 12-volt DC supply. After that, we use a voltage regulator, which will convert it into the 5-volt DC supply, which will be used by all the sensors that we have. We have the band material, which can be a synthetic or cloth material, which will be worn on the hand, arm, or leg. Then we have the GPS, or the global positioning system, which this will be used to get the latitudinal and longitudinal coordinates of the band. Next, we have the HC05 Bluetooth. This is connected to the Arduino and is also connected to the GPS, and it sends all the information from the prototype to the mobile application. Next, we have the temperature sensor. This will be used to check the temperature of the patient at regular intervals. Next, we have the LCD screen, which is placed in the prototype only, and it will show the same information that will be shown in the mobile application, like the temperature, pressure, and the other one information. Next, we have the result. So the result includes the web interface, which will show the geographical location of the patient, and the location will be followed by the timestamp, which will be in hours, minutes, and seconds. Apart from that, there will be alerts which will be provided in case the band is tampered, or in case the patient goes outside the quarantine zone, or in case the patient removes the band. Last, we have the inference. So the project as a whole is something that will help save lives of people by helping in creating a better quarantine environment. The project can be used for other communicable diseases also, and is not specific to COVID-19 only. Apart from quarantining infected individuals, it can also be used for other tracking purposes, like in nursing homes, it can be worn by the elder people so that they can be tracked easily. And unlike other costly tracking devices, this project is cheap, and it not only tracks the location but provides alerts also. These are all the references. Thank you. Thank you, sir.
Thank you, sir. Thank you, sir.
Sir, can we present it now? Yeah, sure, sir. This is Astha.
And I'm Shraddha Parihar.
So our topic is flood disaster prevention using wireless sensor network under the guidance of Mr. R. Subhash. Abstract. So early flood detection and avoidance is a smart system that constantly monitors biological predictions so that we can take necessary precautions or steps to minimize the effect of natural disaster, as they're destructive and can lead to property damage and loss of life also. So in the present system, there is a lack of efficient device to trigger flood alert, and the existing products are quite expensive, flimsy, and wired, which is not suitable for outdoor. And in the current system, a person has to go and check the water level manually, which is time consuming. And our system has a Wi-Fi feature, which is useful to access the system like from anywhere.
And as this system is based on IoT, it means we can monitor it remotely.
Introduction. So, in order to eliminate and minimize the effects of the flood, our system uses a variety of the natural resources to detect the flooding. While river flood damage could be eliminated from a distance from the rivers and other bodies of the water, people traditionally lived and worked in the rivers. The land tended to be flat and fertile, and because river provide easy movement and access to the trade and industry.
Innovation of idea of the project. Our basic motive is to provide an alert system so that we can avoid or overcome the flood risk. It contributes to authorities or companies such as firefighter or any government state agency that can help the society about flooding and natural disaster.
Existing system. So in the present system, there is a lack of efficient device to trigger the flood alert. And the Department of the Irrigation and Drainage could not predict like when will the flood will happen, whether late in night or a day. And in the present system, products are flimsy, wired, and expensive, which isn't suitable for outdoors. Next.
Proposed system. Our model will consist of a sensor, which is also ultrasound sensor that will tell the level of water. And as I've already mentioned, it's an IoT based project, so it can be remotely monitored. And we have used ultrasound sensor, which is used to check the water level up to 15 to 20 meters.
UML design. So this is a UML sequence diagram. So in the input section, we have ultrasonic sensor, which will measure the water level up to 15 to 20 meter. And in the system section, we have battery supply, node MCU, which is an integrated support for the Wi-Fi network, and it has very low energy consumption. And Wi-Fi module, which is useful to access the system and its data over IoT. Next is output section. There we have UBI dot, which will display the final output.
Yeah, so this is the block diagram of a project. So in this project, in this diagram, all the sensors such as GPS location sensor, water level sensor, long range ultrasound sensor, and power supply all are connected with the node MCU. So first, I'll be explaining about microcontroller circuit. So they are small automated computers that are powered by microchip. They enable communication and control over all the things that can be connected to internet, and they have CPU, RAM, and ROM. The next one is long range ultrasound sensor. They produce ultrasonic waves which can be heard by humans, and it doesn't depend on the surface color or physical appearance of the object. And the sensor doesn't require much electricity, which means it's cheap. The next one is level sensor. It is designed to monitor, store, and measure fluid level. Once the fluid is detected, the sensor will convert the data into electrical signals. The next one is GPS sensor. It is used for the navigation system, and GPS and IoT are compatible to create a complete and usable set of connected data.
Modules. So the main idea in our project is to integrate two platforms, Android and IoT, in order to realize a system that is dependable of easy to access at the same time. In order to monitor, store, and measure fluid level, we will be using level sensor. Level sensor measure the level within a specified range in a particular area. To check the water level, we will be using long range ultrasound sensor, which can measure up to 15 meter to 20 meter. So these sensors are placed on the surface of the water. Then the whole system needs power and internet connection to run. And hence, this is done by using a battery and Wi-Fi respectively. So as soon as the water level increases, the circuits get completed, and through GPS sensor, we can find the exact location.
Yeah, experimental evaluation. Like as per our proposed system, the planned stage will introduce as there are two sensors utilized which put at two diverse stature. The first will be set at a lower level. This is the level of a potential flood that will be expected at the point of time. When the water arrives at this level, it triggers and the water sensor. What's more, information is communicated to microregulator and passed to UVI dots for producing an alarm to inhabitants. And as it noticed to be very and arranged event, the water keeps on rising and arrives at the second water sensor. It is viewed as now as a risky and alarm caution will be displayed by and shipped of the inhabitant and specialist.
Algorithms. So we will read the data from the sensor using C library with the help of the node MCU microcontroller. And after that, we will fetch the data and upload it on app called ubear dot with the help of ubear dot library and API. And then data will be displayed. And these are the references we have taken for our project. Yeah. Thank you. Thank you, sir.
Yes, sir. So going to another person here. See, my topic is cardiac image recommendation with anxiety. Sir, my voice is audible. Oh, okay, sir. Yes, now it's okay, sir. So myself as Nanda Gopal, my supervisor is Dr. Sasikla. So my introduction. So my research on this cardiac diseases. Cardiovascular disease are major issues in this in now World Health Organization. See, nearly 17 million people are died from CVD every year. This is a graph shows on say uh, cardiovascular diseases. Most of the heart is coronary heart disease, but then others this and disease of arteries and high blood pressures, then heart failure, like this problems. In this, I chosen the cardiovascular sensor, strokes based problems. In this recent lyrics, major advantages have been the cardiovascular research and practicing aiming to improve the diagnosis and the treatment of cardiac diseases as well as reducing the mortality of the CVD. So modern medical image techniques, MRI, CT, and ultrasounds are the widely used. In this, we some uh, technique to involve our deep learning and machine learning techniques to diagnosis and disease monitoring and treatment planning for this. In this existing method, the segmentation process are did by the mathematical and the various images, Fourier transform like this. So now we enter to the machine learning algorithms. It is a very alternative automatic method to locate and segment the heart-based odd parts and the cardiac images. Some parts like as ventricle, left ventricle, right ventricle, pulse like. In this paper, I discussed about the all existing segmentation methods in deep learning. So these are constantly existing reviews towards the cardiac image segmentation that includes CT scan and MRI and ultrasounds. These are various deep learning approaches are discussed within its advantage and disadvantage to provide the base. The segmentation is done with the regions such as arteria, vertical, and vessels. The limitations and challenges related to the deep learning based approaches. The segmentation functionality like this, some based on the CNN, 2D CNN, 3D CNN, like the more slide is visible. Nice. Okay. Now okay. Segmentation functionality. The segmentation functionality, we give the whole parts of the heart images. We need to segment the heart parts like as left ventricle, left myocardium, right ventricle. It's based on this segmentation problem. Now we discussing the lot of deep learning algorithm. So in this CNN is most used CNN. CNN comparing the stack layers and performing certain functions like pooling, loss functions, and the middle layers. The based on the layers, we doing more accuracy problems in CNN. Same like this 2D CNN, the 2D CNN, 2D input images processing, 2D filter application or it. The intermediate search providing CNN input layer, 2D image format, RGB formats, the analyzing a multi-model images and segmentation. They based on the some 2D CNN is rich the spatial information, single model input. Some it's showing some case high level features are considered the merged together in the 2D. See, same like 3D also we using medical image. Some advantages within the 3D images have the benefits which is spatial information, the multi-scale 3D CNN models and used to for the pathways which is a respective field and respective patches from the sub-sampled image respective. Same time the facilities in this 3D, the higher region for the voxel for benefiting the multi-scale context, like as 3 into 3 kernels, and it gives the more superior accuracy. In this 3D scene is some segmentation algorithm which formulating the images, the deep model used to extracting informative features also. The same like FCN, fully convolution layers. This is like fully convoluted layers submitted to the fully convoluted layers. The auto advancement with the previous models, it's have to have pixel-wise prediction to attain the finest localization performance to active the map to higher resolution in match with the unsampled outputs feed to the convolution layers is assembling to superior outputs. The like the multi-organ segmentation try to segment the CNN or FCN. It's a separate FCN used to 2D sectional view for the modeling and training the approaches. The segmentation output where every pixel is merged with the FCN results produces a segmentation output. So like as UNet and VNet model also, though and RNN. Based on these deep learning algorithms, we spread the application-based structure. The vertical segmentation is 2D CNN, 2FCN, and 2D unit plus 3D CNN ensemble. The like hybrid algorithms are already discussed used in the. So they are structured the biventricle based. Then article segmentation using the multi-view CNN with adaptive fusing statistic, 2D stage pipelines, 3D unit localization plus 3D unit segmentation is for the left arterial. Then arterial segmentation for the RNN to learn temporal coherence to ortho. Then like as scar segmentation using the multi-alternance method for the LA segmentation followed by an AE to find the article scars. The like same thing, the fully automated multi-view to task regression attention also for article scars. Then whole heart segmentation using 3D unit with deep learning uh, unit with deep supervision, then the dilated CNN with the deep supervision, the 3D FCN with deep supervision. These are using for the whole art blood folds, myocardium, then of the heart. There's like a cardiac substructure segmentation. This substructure segmentation is used to uh, uh, segment the all parts of LV RV like this. Using the multi-plan FCN with an adaptive fusion strategy like 3D unit with deep supervision. This is all the MR scan or the CT scan the images using the coronary artery segmentation for this CNN as path tuning, the multitask FCN, then 3D FCN with the level set, the CDN estimation direction classification are using for the coronary artery segmentation. So in this segmentation problems, we are using to next level. Then way to address this deep learning approaches, so improved segmentation with better accuracy model and as the ability to deal with the complex functionalities. This deepening network to carry out the training task, collecting the huge amount of the samples and medical image processing is considered to complex tasks. Various approaches still under the investigation for handling these issues. The medical image processing is extremely complex for having the image annotation is extremely and the transfer learning is executed to the same region to solve these issues. This conclusion we are discussed in this paper, but the some of challenges are encountered in the deep learning models. Overfitting occurs while capturing regularities and the patterns in the training set with the better accuracy. At the same time, the data set size and the solution of providing increasing data sets, then uh, view they create in a single view and validate the positive effort, reducing the training time and the fast converses. Things are discussed in the paper. At the same time, the advantage and disadvantage of the modalities CNN, FCNN, UNet, and VNet and RN models. At the same time, the image and inputs like as CT, MRI, and ultra images. The challenges, the limitation encountered in the those models are analyzed, therefore modeling an effort approach so better engagement in the segmentation domain using the good for good accuracy. We discussed and listed the some application oriented results. Thank you, sir. These are my references. Sir. Thank you, sir. Sir, it's not response low. So voice is too low, sir. Okay, okay, sir. Okay, sir. Okay, sir. This is it's yes, sir. This my it's a segment is a first initial step, sir. I have a plan to do next. Okay, 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 sir. Okay, sir. Okay, sir. Okay, sir. Thank you, thank you, thank you, sir. Thank you for the opportunity.
Sir, shall we proceed?
Yes, sir, I'm presenting it. Yes, sir. Can I start?
Right, sir. Right.
Sir, actually, there's another batch, sir. Me and Sudarshan.
To all the members present in the conference, my name is Anurag Singh. Our project aims to classify
Okay,
the
okay.
people who are not so famous and have a bad background, such as the politicians, the criminals or the most wanted people all around India, the social reformers who are building changes necessary for our nation, and the sport athletes who are making our nation proud around the globe. This is trying to spread the awareness among the inhabitants of the country, as they will come to know about these unknown people and what they did in the past, and can also be used for investigation to keep a record on the past criminals. Image classification falls under the supervised machine learning technique and uses various classification algorithms to identify a particular image label. The aim of the project is to identify the said person and provide some amount of information that they did before or achieved something to be so famous to be included in our project. Even nowadays, there are a majority of people who are unaware and uneducated about many things, be it any subject related to education, general knowledge, or basically anything. And those who are even educated with some amount of information in any field should spread it and make people aware of it, as it would lead to the benefit of society as a whole. Our country, India, is a democratic country where people choose their leaders after any specific interval of time. No matter how good are the leaders, there are some dark past record that is not known by the people, and sometimes people don't even know the persons in general as they are so famous. The people who have already succeeded in life can be the biggest source of motivation and can be set as an example for other people to succeed in life and hence achieve their dreams. But the inhabitants of our country have a right to know about
Yes,
various
sir. Yes,
aspects
sir.
of the
One
process,
second.
also such as the politicians having a bad background.
Yes, sir. Yes.
Sir, we Yes, sir. Shall I present? So, sir, shall I present me and Sudarshan?
Yes, sir.
Okay, sir. Sir, is my screen visible? So the topic is smart framework for products and communication segment of society, and done by me and Sudarshan, and guided by R. Subhash sir. The abstract is like the app name is AgroAid. The AgroAid is a mobile application device for assistance to supply chain management in India using smart framework for products in the society. The purpose of this application is to merge Android development and machine learning techniques to develop an app that maintains a transparent and easy activity of supply chain management system in India. Producers, suppliers, and customers are the major components covered in this project. The app will step of our product development, right from the primary producer to the customer. We propose to carry out this using Android application and machine learning techniques. It is an effort to elevate smart city and communication. The producer sector include the farmers and other primary producers. The supplier sector will involve suppliers and companies to carry out necessary supply management tasks. The consumer section will customers to track their shipment and maintain orders. Solution? Solution?
Yes.
Can I continue with the features of the app?
Sorry.
Continue with the features of the app, like to it in short.
Yeah, sir. Basically this app is for mainly concentrated for the farmers. So farmers generally give their products with a low cost of rate to the agent. Then the agent comes to the retail shop and he gives for a higher rate. By using this app, farmers can directly contact to the customers and give it to a good rate, and they can make profits more than giving to an agent. There will be no agent in the middle of the customers and the farmers. This is the main concept.
So these are some snapshots of the apps here. It's a login page, and there's three modules actually: supplier and customer and producer. The producer is like farmer login, and supplier is acquiring the raw material from the farmers and processing it for and making it into a product. And the third module is customers. If you log in as a supplier, these are the features, sir. Like maintenance, like to maintain your all your what to say your industry equipments and this feature market value estimator is to estimate raw material values, rate of market rate of raw material like cotton or something. estimate is can be seen using this one. And the supplier can post like X or V or something, whatever they want to, so that the customer can see using their login. And, this is customer login, like the features like chatbot and delivery tracking, etc. And the chatbot is done using IBM options. So that's the overall concept. In short. So, sir, I'm done with the presentation. Sir, can you hear me?
Sir, hello, sir.
Sir, sir, you online? Excuse me, sir. Sir, I'm done with. Sir, I'm done with the presentation. Sir, I stopped sharing. Yes, sir, Nikhil and Sudarshan done with the presentation. Yes, sir. No, sir. Me and Sudarshan are together. Nikhil and Sudarshan. Yes, sir, we are done with the presentation, sir. Yes.
Sir, can we leave, sir?
Can you see my screen? Okay, sir. Okay, sir. Sir, this is Gogula Hampi. My project is handwritten text recognition using machine learning algorithms. I am under the guidance of Mr. R. Rajkumar, sir. The abstract. In our project, whatever we upload will come in the form of original text. We are using MATLAB to do our project. We can upload scan document or a paint image. Here the application is alphabetic letters assigned with numericals. Sir, hello. I'll just finish it. It is mainly of three main processes, sir: pre-processing method, segmentation method, and classification. In pre-processing method, we enhance the images to get the picture of the handwriting. Um, uh, uh, the picture may have the low brightness, high contrast. We remove this in pre-processing method. Uh, yeah, there are two domains: special domain and pre-considered domain. In special domain, if the brightness is high, or if we want to resize it, we'll do them in special domain. And in pre-considered domain, we remove the noises uh, and we remove the noises using filters. There are many types of filters. Here we are using median filter. And after pre-processing method, we'll do segmentation. In segmentation, we'll segment that part by k-means clustering method. To segment the part, we'll convert the image from RGB to grayscale. Here we are converting to get the segment part required. And in classification, we train the data sets. It is done in three different methods: feature extraction, label, and measurement. After uh, uh, suppose if we give an input name like Humpy by after classification, with a feature extraction, label, and measurement, we'll get the and after training the data sets, we'll get the output required. And this is our code, and this is the screenshot of the output we tried, sir. We are till now all the handwritten projects are used only one language. In our project, we are using trying to use two languages at the same time, English, and we are also trying to add Telugu to our project. These are references, sir. Yes, sir, done. What, sir? Yes, sir. Yes, sir. Yes, sir. It is. It is 72% accurate, sir. We are using support vector machine algorithm. In this. Thank. Sir, we both are in quarantine, sir. Me and my partner. So sorry, sir. Very sorry, sir. Thank you, sir. Thank you so much. Thank you so much. Sir. Thank you so much.
Thank you so much.
Thank you, sir. Thank you, sir.